Hey guys, good morning. අපි අද දවසේ පළවෙනි සෙෂන් එක සම්පූර්ණ වශයෙන් තුන්වෙනි සෙෂන් එක අපි පටන් ගන්නෙ. මම නැවතුනේ අපි ඊයේ අපේ පළවෙනි රිසර්ච් පේපර් එක කියවලා අවසන් වුණා. එතකොට ඒ රිසර්ච් පේපර් එක මෙතන මම R1 කියලා දාගෙන ඉන්නේ. සම්පූර්ණයෙන්ම මම රිසර්ච් පේපර් එකේ අදාළ දේවල් ටික මම කරගෙන යමින් පවතින්නේ. මම පොඩි ඉස්මගේ රෝඩ් මැප් එක ඊයේ 3:30 තමයි අපේ රිසර්ච් පේපර් රයිටින් සහ රිසර්ච් එක සම්පූර්ණ රිසර්ච් එකක් කරමින් රිසර්ච් පේපර් රයිටින් එක කරගෙන යන්නේ. මේක ඊටම ක්වික් විදිහට කරන රිසර්ච් එකක්. ඒ වගේම මම end to end මේක විස්තර කිරීමක් සිදු කරනවා. ඒ කියන්නේ දැන් මමත් ඔයාලා වගේම කොහොමද රිසෝර්සස් හොයාගන්නේ, ඒ වගේම කොහොමද රිසර්ච් එකට ප්‍රවිෂ්ඨ වෙන්නේ, ඔය සියල්ලම අධ්‍යයනය කරමින් තමයි මේක කරගෙන යන්නේ. ඒ කියන්නේ ඔයාලට එතකොට ග්‍රවුන්ඩ් වර්ක් එකේ ඉඳලම කොහොමද රිසර්ච් එකක් කරන්න කියන අයිඩියා එක දෙන්න තමයි ඒක එහෙම කරගෙන යන්නේ. ඊට පස්සේ මගේ දැන් මම දාගෙන තියෙනවා මගේ සාමාන්‍ය leisure hours, ඒ කියන්නේ එක වැඩ සඳහා තියෙනවා 6:30 to 8 1:30 hours. ඊට දැන් 8 ඉඳලා 12:00 වෙනකම් මම ඒකට මේ සෙෂන් එක යනවා. ඊට පස්සේ 12:00 දෙක වෙනකම් මම ගන්නවා 1:30 hours මගේ අනිකුත් වැඩ සඳහා ටයිම් එක. ඊට පස්සේ 7 to 9 කියන එක අපි හදාගත්ත 7 to 10 කියලා. 7 to 10 දක්වා 3 hours ගන්නවා. ඒතර සාමාන්‍ය efficiently 15 hours අපි use කරනවා කිව්ව මේ මෙතේට. එතුන් නිදා ගන්නත් අපි use කරනවා කිව්ව 4 hours. right? ඊට පස්සේ අපේ magic 5 years research එක භාවිතා වෙන novelty එක කියන එක මේවට එක ස්කෝර්ස් දීලා තියෙන එක රිසර්ච් පේපර් එකට අනුකූලව novelty එක. ඊට පස්සේ research gap එක කියන එක. ඊට පස්සේ significance එක කියන එක. ඒ වගේම commercial viability එක. ඒ වගේම resource availability. ඒතර යම් කිසි topic එකක් තෝරගනිද්දී මෙන්න මේ 5 magic 5 pillars ටිකට අනුකූලව ඔයාලා මේ අදාළ topic එක plan කරගන්න ඕන. right? ඒතකොට සාමාන්‍යයෙන් ඒකට අපිට review paper එකක් pages 30ක් තියෙන එකක් අපිට මේ කියවලා අපිට ඒ අදාළ knowledge එක ගන්නට 1 to 2 hours තමයි අපි estimate කරේ. නමුත් ඊට වඩා වැඩි කාලයක් ගියා ඒක paper එකක් අපිට බලන්න. මම ඔයාලත් එක්ක විස්තර කරමින්ම ගියේ. නමුත් අපිට දැන් ඒක අඩු කරගන්න ඕන. දැන් ඒක efficiently කොහොමද අපි අඩු කරගන්නේ? දැන් එතකොට ඔන්න ඊයේ දවසේදී ඇතිවෙච්ච mistakes එකක් දැන් මම ඔයාලට explain කරද්දි සෑහෙන කාලයක් ගත්තා. ඒ වගේම pages 30 ඒතකොට plan කරගන්න බැරි වුණා. සාමාන්‍යයෙන් පැය 3:00 වගේ ගියා අපිට ඒ paper එක finish කරන්න. අපි හදුවේ පැය 4ක් විතර. ඒක ලොකු කාලයක්. එහෙනම් අපි ඒක අඩු කරගන්නේ කොහොමද කියන එක දැන් බලනවා. දැන් අපි පුළුවන්. right? එහෙනම් දැන් මම යනවා මගේ software එකත් මම open කරනවා. software tool එක දාගන්න විදිහ සහ software tool එක මොකක්ද කියන එකත් session 1 එකේදී මම විස්තර කරලා තියෙනවා. right. එහෙනම් software එකට ගියා. මම දැන් මම බලලා ඉවර වෙච්ච research paper එක තියෙනවානේ. දැන් මෙතන research papers මේ direction කියන එකට අදාළව research papers තියෙනවා 1 2 3 මෙතන count එකක් කියනවා දැන් තියෙනවානේ 24 items. 24 items තියෙනවා. මේක research papers 24ක් තියෙනවා. ඊට පස්සේ මේ satisfaction එකේ තව තියෙනවා. මට සෑහෙන research papers මම already අරගෙන තියෙන්නේ. ඊට පස්සේ තව අවශ්‍ය නම් මට පුළුවන් ගන්න. ඒක මම ඒව ගන්න විදිහත් ඔයාලට කියන්නම්. Google Scholar සහ අනිකුත් repositories වලින් අපිට ඒව ගැනීම හැකියාව තියෙනවා. ඒතකොට මම දැන් එකක් බලලා ඉවරනේ. මේ බලපු එක අපිට පුළුවන් දැන් ඒ බලපු එක දැන් මම ඒක සම්පූර්ණයෙන් බලලා ඉවරයි. සම්පූර්ණ බලලා ඉවර එක අපිට මේකෙන් අපිට දාගන්න පුළුවන් වෙනම repository එකකට. ඒතකොට මට ඒක අපිට new collection කියලා එකක් දාලා reviewed කියලා දාන්න මම reviewed කියලා දැම්මා. reviewed කියලා දාලා reviewed R1 කියලා දාන්නකො. R1 එතකොට මට තේරෙනවා මේ R1 ට දාලා review වෙච්ච ඒවා. හරිද? මේ එතන මේ direction කියන එකෙන් මම ගත්තේ මොකක්ද මේ මෙන්න මේක decoding of upper limb anyway කොයි අප්පා නෑ ඒක මම ගත්තේ ස්පීච් කියලා එකකද නෑනේ ඩිරෙක්ෂන් වෙන්න ඕනේ ඩිරෙක්ෂන් එකේ මම මේක ගත්තේ අර අපේ ටිප් එක මේකට ඕපන් කරලා බලමු මේකද කියන එක නෑ මේකද ඊට පස්සේ මේක වෙන්නේ මේ දින right ඕකනේ අපි රිවිව් කරපු විතර රිවිව් විදිහට මේක එනවා කෝ right මේක දැන් මට ගන්න මම බලමු මේක දැන් කට් කරලා ගන්න පුළුවන්ද කියලා add to collection add to new collection add to මේක දාමු add to collection මේක දානවා reviewed R1 කියන එක. දැන් ඒතර ඒක එනවා reviewed R1 එක. දැන් මේක ඇවිල්ලා තියෙනවා. දැන් මේක review කරපු එකක් එතකොට දැන් මම මේකේ දාගන්නවා දැන් මම දැන් අපි කරපේ වගේ අයිඩියා එකක් තියෙන්නත් ඕනේනේ. එතකොට ඔන්න මේ 11 කියලා මම ගිහිල්ලා තියෙනවානේ. ඒ ගිහිල්ලා තියෙන්නේ unsaved file save කියලා. right save that. save. හරිනේ. right okay. තුරන්න ඒ R1 කියන එක R1 කියලා මම අධ්‍යයනය කරන එකට දැන් අර අලුත් කලෙක්ෂන් එක රිවිව් කියලා මම පාවිච්චි කරා. ඒකදී යන්න අරගත්ත ඒ අදාළ ටික. දැන් මම දැන් දෙවෙනි රිසර්ච් පේපර් එක අධ්‍යයනය කරනවා. නමුත් ඒක ටිකක් මම efficient විදිහකට අධ්‍යයනය කරන්න යන්නේ. දැන් මොකද්ද මම ගන්නෙ? දැන් මෙතන මම දාලා තියෙන රිසර්ච් පේපර්ස් ඔක්කොම වගේ මට යම්කිසි විදිහකට මගේ මේ data අදාළයි. හරිද? නම් දැන් මම ටිකක් ඔය ස්පීච් සින්තසිස් කියන එකට අදාළව දැන් මගේ අයිඩියා එක වෙන්නේ මොකද්ද? කතා කරන්න බැරි කෙනෙක්ට මේ virtual sound එකක් නිර්මාණය කරන එක. ඉතින් මම මෙතනින් ගන්නම් මේ දිනේ towards an EG intuitive DCA communication system using imaging spaced and visual. මේක මම හිතනවා දැන් ඒක ගොඩක් දැනෙන එකක්. ඒක පිටු 6ක් තියෙනවා. දැන් මේක තමයි ඔන්න රිසර්ච් පේපර් එක ෆෝමැට් එක. ඒ කියන්නේ මේ විදිහට ඩබල් සයිඩ් ගිහිල්ලා ඔය ආකාරයෙන් තමයි රිසර්ච් එකක් තියෙන්නේ. හරිද? දැන් මේක රිවිව් කරාට පස්සේ මම මේකත් දාගන්නවා අතෙන්ට. එතකොට දැන් මේක මම අරකේ ටොපික් එකක් ඕනනම් දාගෙන මේක හොඳයි. ඒතර මට ටිකක් දැන් වැඩේ ටිකක් ලස්සනයි ප්ලෑන් වෙනවා. මම මේ ටොපික් එකක් දාගන්න. ඒතකොට මට මේක අධ්‍යයනය කරද්දී පහසුවක් වෙනවා. right මේක දැම්මා. මේක දැන් මේක තමයි අධ්‍යයනය කරන්නේ. මම මේකට මේ කරා දැන් මේ පේපර් එක අධ්‍යයනය කරන්න යන්නේ. හරිද? දැන් බලන්න දැන් මේක ඇබ්ස්ට්‍රැක්ට් එක කියවද්දි දැන් මම පොඩ්ඩක් මේකේ මේට්‍රික්ස් එකක් හදා ගන්නවා. හරි මේ මේට්‍රික්ස් එකේදී මම කරන්නේ මම ටක් ගන්නකොට පැරෆ්‍රේසින් මෙතඩොලොජි එකක් යූස් කරනවා. ඒ කියන්නේ ඇබ්ස්ට්‍රැක්ට් එකෙන් මොකක්ද ඇත්තටම කියන්නේ. මම ඒ ටක් ගන්නකොට බලලා මම ගත්ත අයිඩියා එක දා ගන්නවා. හරිද? මම එතකොට දැන් හැම එකම කියව ඉන්නේ නැහැ. ඒතකොට එකක් අර කතා කරගෙන යද්දී පොඩ්ඩක් අපහසු වෙනවා. ඒ ඉඳ මම මෙතන හදා ගන්නවා මේ ඉන්සර්ට් කරන ටේබල් එකක්. හරිද? මේ ටේබල් එකේ මම දා ගන්නවා ඇබ්ස්ට්‍රැක්ට් එක. ඊට පස්සේ ඉන්ට්‍රොඩක්ෂන් එක. ඊට පස්සේ ලිටරේචර් රිවිව් වල. ඊට පස්සේ ඒකෙදි ඒ ලිටරේචර් රිවිව් ටික ඊට පස්සේ ඒකේ ඉම්පෝටන්ස් මොනවා හරි තියෙනවා නම් තව කොලම් එකක් දානවා. මම මේ කොලම්ස් මේවා මේ කරගෙන යද්දී නම් කරනවා. එතකම මම කොලම්ස් ටිකක් ඔය විදිහට සෙට් කරනවා. මම මේකේ මේක ඔය දෙකකට වෙන්න තිබ්බම ප්‍රමාණවත්. මොකද ඊට පස්සේ මම මේක ටිකක් ලාර්ජ් කරලා ගන්නවා. right දැන් ඊතර මම මෙතන මේ කරන්නේ මේ ප්‍රමාණයට වෙන්න හදාගන්න. නැත්නම් මම මේකත් එක්කම දැන් අපි එක පොඩ්ඩක් මේක ඉරේස් කරමු control Z කරමු. මම මේකත් එක්ක Excel sheet එක ආරම්භ කරනවා. Excel sheet එක ආරම්භ කරන්න. ඒතර ලේසි මොකද Excel sheet එකේ අපිට ඒක plan කරගන්න පහසු වෙන්නේ. මේකේ මම මේක සේව් කරගන්න R1 කියලා R2 නේ R2 කියලා දාන්නම් මේක මේක දාමු R2 කියලා දැම්මා සේව් කරනවා මෙතනට ඒකත් එක්ක යනවා මේ Excel sheet එකේ දැන් මේ R2ට අදාළව මම මේකේ දේවල් ටික මම මෙතන plan කරගන්නවා මොකද මේ R2 වලින් මම ගත්තේ මේකේ abstract එක තියෙනවා නිකන් දාගෙන යන්න abstract එක abstract එක ඔය ඊට පස්සේ මෙතන දාමු අපි introduction එකකින් හරි මම පස්සේ වෙනස් කරගන්න මම දැන්ට නිකන් කොලම් ටිකක් දාගෙන ඒක දැන් plan කරගන්න තමයි මම හදන්නේ අපි දාමු introduction එකේ මොකක්ද මෙයන් අදහස් කරේ තියෙන importance දාමු නමුත් ඔහොම නෙවෙයි ඊට පස්සේ දැන් මම ඒක කරගෙන යද්දි මට එනවා මොනවද මේකට දාන්න ඕනේ එහෙනම් දැන් abstract එක මම කියවද්දී communication using brain computer interface has developed in attempts towards an intuitive systems by decoding the imaging space or visual imaging දැන් මේකේ ප්‍රධාන තේමාව වෙන්නේ imaging speech or visual imaging කියන image. However, discrimination between the two paradigms may be ambiguous because the user intention contains their original meaning. The clear distinction between two paradigms may facilitate the active use of them, leading to an intuitive BCA conversation system. In this study, we compared imaging speech and visual imagery in the perspective of its presence, spatial features, and classification performance based on electroencephalography. 7 subjects performed both imaging speech and visual imagery of 12 words and phrases. We showed the presence of the two paradigms, having distinct brain region from each other. The maximum 13-class classification accuracy include this class was 34.2 for imaging speech and 26.7 for visual imagery. Therefore, we investigated the possibility of multi-class classification of more than 10 classes of both paradigms, showing the potential of them to be used in the real-world communication system. These findings could further be utilized in the intuitive communication for lockdown and parents sending commands in the external world simply by thinking the very thing that the user wants to deliver. Then මෙතනදී මේකේ කියුවම මට එන අයිඩියා එක වෙන්නේ මෙයාලා compare කරලා තියෙනවා මොකද්ද imagine speech කියන paradigm එක BCI වල versus අනිත් එක තමයි visual imagery. හරිද? ඕක තමයි උතන අරගෙන තියෙන්නේ. දැන් එතන යන concept එක ඒ idea එක මම ගත්තා දැන්. right? එතකොට abstract එකේදී එයාලා ඒකෙදි කොච්චර subjects use කරලා තියෙනවද? ඊට පස්සේ idea එක දීලා තියෙනවා. ඒතර main idea එක වෙන්නේ මම Excel sheet එකකට දාන abstract එකේදී මේක කරන්නේ visual imagine speech versus visual image. ඕකනේ නේද? ඔක තමයි මගේ මේ concept එක වෙලා තියෙන්නේ. බලුවම visual image. ඊට පස්සේ මේ ඇයි එහෙම එකක් නෑන කරන්න හේතු වෙලා තියෙන්නේ? However, discrimination between the two paradigms may be ambiguous because the user intention contains their original meaning. A clear distinction between the two paradigms may facilitate the active use of them, leading to an intuitive VCI conversation system. In this study, we compared imaging speech and visual imaginary in the perspective of its present spatial features. And මේවා එයා අධ්‍යයනය කරලා තියෙනවා. දැන් ප්‍රශ්නේ වෙලා තියෙන්නේ මේක සමහර අවස්ථාවලදී මේ visual imagery කියන්නේ මොකක්ද? ඒ වගේම imaging speech කියන්නේ මොකක්ද කියන එක ගැන මේ අර clear idea එකක් නැහැ. අන්නේ clear idea එක දෙන්න තමයි මේ paper එක එයාලා publish කරලා තියෙන්නේ. To give a එතකොට එතනම මම දාගන්නම්. මම Excel එකට අවශ්‍ය features ඒ වෙලේ දාගන්නම්. ඒ වගේම මම මගේ මේක ඇද්දි මේක පුරත් කරලා කරන මෙතන එකක් තමයි මෙතන to give clear idea between two paradigms. ඊට පස්සේ එනවා දෙන්න ඊට පස්සේ මෙතන අපිට result එක ඇවිල්ලා තියෙනවා visual imaginary එකට වඩා සුළු accuracy එකක් වැඩි මොකේද imagine speech එකේදී හරිද ඊට පස්සේ මේකේ subjects කොච්චර පාවිච්චි කරාද කියලා තියෙනවා ඊට පස්සේ මෙයාලා පාවිච්චි කරලා තියෙන මේ parameters ගැන විස්තර කරලා තියෙනවා perspective of its present spatial features classifications performance based on spatial features. It was a classification performance. There's a spatial features and classification performance based on EEG are considered. මෙන්න මේවා මේ parameters තමයි උඩ සංසන්දනය කරලා තියෙන්නේ. right abstract ඊට පස්සේ introduction එකට ගියාම introduction එකේ ගත්තොත් දැන් මම මේකට යන කාලෙත් මම බලන්න 24යි ඒකට කාලට වගේ පටන් ගත්තේ මේ මේක අධ්‍යයනය කරන්නට බලමු කොච්චර වෙලාවක් යයිද කියලා introduction එක ගත්තොත් decoding and converting human thought onto outside world so are called reading the mind. Decoding and converting human thought into outside world, so as called reading the mind, that is to interpret internally generated speech. Okay, has been a long-held ambition of a brain-computer interface in respect of VCA communication system. Various VCA spellers using P300 steady-state visual evoke potential and motor imaginary had been developed. However, these conventional speller system hold several drawbacks. Reliance on external disably use කරන්නා වූ P300 steady state visual evoke potential and motor imaginary had been developed. However, these conventional speller system hold several drawbacks තියෙනවා. Reliance on external stimuli. මොකක්ද external stimuli එකක් මත රඳා පවතින එක. Display equipment ඒ වගේම equipment display කරන්න ඕනේ and the mental task being conversation irrelevant. ඒ වගේම mental task එක conversation එකත් එක්ක irrelevant කියලා කියනවා. එතකොට මම දානවා මෙතනින් මම දාගෙන යනවා conventional BCL paradigms like P300, SSVEP, motor binary has drawbacks. Non-drawbacks rely on external stimuli. Again, display equipment. Display equipment සලවුල display කරන equipment සලවුල සහ ඊට පස්සේ මොකද තව කිව්වේ conversation irrelevant. Conversation irrelevant. මේකට මම සයිට් කරන්න මොකක්ද මම සයිට් කරන්නේ මේ දෙකනේ ඒ කියන්නේ V2 එකනේ ඒතර මේක මම මගේ රිසර්ච් පේපර්ස් වල ගත්තොත් දෙවෙනි එක කියන එක ගන්නවා right ඊට පස්සේ BCA the P300 SSVP is an exogenous BCA paradigm. P300 එක අපි කරන්නේ ඒක exogenous BCA paradigm that requires external stimuli. දැන් අපි දන්නවා P300 SSVP වලට අවශ්‍ය වෙනවා exogenous and requires external stimuli. Therefore, additional display equipment is essential to be operated. ඒතර additional display equipment එකක් අවශ්‍ය වෙනවා ඒකට. දැන් මේ ප්‍රකාශ කරන දැන් මෙයාලා අර visual imagery කියන එකට සහ imagine speech කියන එකට යන්නට කලින් විස්තර කරනවා traditional paradigms වල තියෙන දුර්වලතා ටික. ඒතර මෙතන කියන P300 එක සහ SSVP එක rely on external stimuli. මේ exogenous කියන එක ඒක වැදගත්. අපි කලින් කතා කරා. නමුත් අපි ඒක note එක කතා කරන්නේ නැහැ. ඒවා exogenous BCA paradigms that require external stimuli. Therefore, additional display equipment is essential to be operated. So the additional display equipment එකක් ඒ කියන්නේ speller device එකක් වගේ එකක් අවශ්‍යයි මේකදී operate කරන්න. In addition, the mental tasks used in the conventional spellers in addition, the mental tasks used in the conventional spellers generally have little or no correlation with the message. ඒ වගේම මේ mental task එක in addition to the mental tasks used in the conventional spellers ඒ කියන්නේ මේ සාම්ප්‍රදායික මේ spellers වලදී use වෙන මේ mental task එක have little or no correlation with the message that is being conveyed. ඒ කියන්නේ අපිට convey කරන්න ඕන message එකත් එක්ක තියෙන correlation එක සහසම්බන්ධතාව අඩුයි. මම ඒකත් දාගන්න මෙතන දැම්ම P300 SSVEP are exogenous. BCA paradigm rely on external stimuli need additional display devices and also message conveying does not have a correlation with the mental task. එන අඩුයි කියලා කියන්න ඕනේ අපි හදාගත්ත පස්සේ therefore additional to be operated so no correlation with the message that is being conveyed, making them difficult to intuitive to be performed. Hence, an intuitive BCA system that decodes the very thing the user is thinking about is necessary. දැන් ඒතර දැන් මේ තියෙන drawbacks නිසා making them difficult and unintuitive to be operated. කියන්නේ මේක අපහසුයි ඒ වගේම අපේ ඒකේ තියෙන අභ්‍යන්තර මානසිකත්වය කියන එක perform කරන්නට අපහසුයි. Hence an intuitive BCA system. ඒතර intuitive BCA system කියන කාණ්ඩයක් අපිට කතා කරන්න සිද්ධ වෙන intuitive BCA system that decodes the very thing the user is thinking about is necessary. දැන් මේ user think කරන එක හරියට think කරන එක මොකක්ද කියලා ගන්න අපි ඔය intuitive BCA system එකක් නිර්මාණය කරන්න අවශ්‍යයි. For example, in case of the user intended to enter an apple to the system. දැන් අපි හිතමු මේ user ට ඕනේ enter කරන්න apple කියලා. apple කියන වචනේ system එකට enter කරන්න අවශ්‍යයි කියලා instead of observing a flickering monitor or imaging the movement of his hand. දැන් මෙයාට apple කියන එක මොකක්ද enter කරන්න අවශ්‍ය system. Instead of observing flickering monitor or imagining the movement of his hand, the user only has to imagine an apple itself. Instead of observing a flickering monitor, again, flickering monitor එක දිහා බලාගෙන or imagining the movement of his hand. Again, අපේ අතේ movement එක ගැන හිතන එක බලකලා the user only has to imagine an apple. මේ user ට ඕන වෙලා තියෙන apple කියන එක right එතකොට apple කියන එක by directly decoding the user intention without going through additional steps. It doesn't require an external stimulus, no additional training to the user. Therefore, it can be lead to extreme convenience to the BCA communication system. I mean, intuitive approach එකේදී දැන් අපිට නිකන් මොකක් හරි display එක flicker වෙන monitor එකක් දිහා බලාගෙන Apple එක දිහා බලාගෙන ආයෙක Apple කියලා enter කරන එක කියන එක වගේ නෙවෙයි. අපි දැන් Apple කියන එක හිතුවොත් අපිට Apple කියන එක enter කරන්නට පුළුවන් වෙන විදිහට සකස් කරගන්නට අවශ්‍ය වෙන example එකක් තියලා තියෙන්නේ. අපි ඉවත් for the example, in case of user intending to enter an apple to the system instead of observing a flickering monitor or imagining the movement of his hand, අපිට ඕනේ apple කියන එක enter කරන්නට flickering monitor එක කාස්ට් කරගන්න නැතුව ඒ වගේම movement එක hand එකේ මොකක් හරි movement එකක් ගැන හිතන්නේ නැතුව the user only has to imagine that. ඒ කියන්නේ අපේ අතේ movement එකක්වත් මුකුත් හිතන්නේ නැතුව apple කියන වචනය විතරක් ඒක අපිට enter කරන්නට අවශ්‍යයි කියලා හිතන්න. By directly decoding the user. ඒතකොට directly decoding the user intention without going through additional steps. ඒ කියන්නේ user ගේ intention එක තියෙනවා. ඒ කියන්නේ apple කියන එක හිතන එක ඒක enter වෙන්න ඕන. It doesn't require an external stimulus, no additional training to the user. Therefore, it can be lead to extreme convenience to the BCA communication system. Right? However, imagining an apple itself may differ depending on the users. Some users might imagine pronouncing apple. Right then, mama මේක පොඩ්ඩක් පැහැදිලි වෙන්නට මම පොඩ්ඩක් ලියාගෙන අතන කම්පියුටර් එකේ intuitive BCA system significance. මේකදී මම apple කියන උදාහරණ ගන්නවා. If need to enter an apple to the system without using a flickering monitor or without movement of the hand. දැන් මේ ලියාගත්තොත් අපිට ඒක මතකයි. මම දැන් කියපේ movement of the hand just directly imagine the bird apple. ඒක මොකද වෙන්නේ? ඒතර it does not need of external stimuli directly and decoding directly decoding customer solution directly decoding so it is easy convenient කියන එක දාන්න තමයි පහසු වෙන්න උදාහරණ දාගත්තා right okay මේක දාගත්තා ඊට පස්සේ however imagine an apple itself may differ depending on the users then imagine apple කියන එක imagine කරන එක users ලා මත depend වෙනවා some users might imagine pronouncing apple whereas other might imagine the shape of an apple සමහර කට්ටිය apple කියද්දි apple pronounce කරන apple හිතද්දි apple කොහොමද pronounce කරන්න කියන එක හිතනවා සමහර කට්ටිය apple වල shape එක ගැන හිතනවා it brings up two related BCA paradigms then making two related BCA paradigms imagine speech and visual imagination දැන් ඔය බලන්න මේක ලස්සනට විග්‍රහ කරලා තියෙනවා මේ two BCA paradigms වෙන imagine speech කියන එක සහ visual imagery කියන එක දැන් එතකොට මේ Apple කියන එක pronounce කරනවා කියලා කියන්නේ ඒක හරියට speech එකක් generate කරනවා නේ speech එකක් generate කරන්න හිතන එක Apple කියන එක දැන් අපිට කියන්නට ඕන හරිද Apple word Apple එක කියන්නට ඕන එතකොට ඒක imagine speech එක ඊට පස්සේ Apple එකේ shape එක අපි මවා ගන්නවා කියන එක ඒක visual imagery හරිද imagine speech and the visual image. The imagine speech is first person motor imaginary of speaking, and the imagine speech is first person motor imaginary pronouncing the verb, whereas other might imagine a shape of an animal. It brings up two related BCA paradigms: imagine speech and visual imaging. The imagine speech is first person motor imaginary of speaking, in which the speaker feels as though they are producing speech without an articulatory movements. Imagine speech එකක් කියලා කියන්නේ the person imagine speech is first person motor imagery of speaking. Motor imagery කියලා කියන්නේ එයා මේ මුකුත් movements වලින් තොරව එයා මේක කියන්නට උත්සාහ කරනවා. කියන්නට මේ කියන්නේ ඒක imagine ඒක මේ වචනය නිර්මාණය වෙනවා. හරිද? Imagine speech the imagine speech is first person motor imagery of speaking, in which the speaker feels as එයාට හිතෙනවා feels as though they are producing speech. මෙයාට මේ Apple කියන වචනය ඔන්න කියවෙනවා කියන හිතන එක. ඒක අපි කියනවා motor imagery of speaking without producing the sound. And they are producing speech. They feel like producing the speech. Motor imagery. Motor imagery of speaking, in which the speaker feels as though they are producing speech without any articulatory movement, without any articulatory movements. Again, කිසිම movement එකක් නැතුව කියන්නේ muscle movement එකක් නැතුව without any articulatory movements. හරිද? මම ඒක දාගන්න. මොකද ඒකට කියන්නේ imagine speech. Imagine speech මේ definition වැදගත්නේ. Motor imagery of producing speech, producing speech, feeling as the speech is produced without any articulatory movements. Era imagine speech එක the left inferior frontal lobe. Inferior frontal lobe එකට කියනවා Broca's area කියලා. Left inferior frontal lobe, Broca's area. Left superior temporal lobe ඒකට කියන vernix area and motor cortex are known to be activated during emergence. දැන් මේ තුන මේකෙදි මේ වෙනවා කියලානේ ඒක ඒවා ඇක්ටිවේට් වෙනවා කියන. දැන් ඒක කෙලින්ම කොපි කරලා මම දාගන්නවා. මොකද ඒක එයාලා අරගෙන තියෙන එකක්. එතකොට මම ඒක ලියන්නට මහන්සි වෙන්නේ නැහැ. ඒකත් එතන imagine speech එකේදී ඒවා මේ වෙනවා කියලා දීලා තියෙනවා. ඊට පස්සේ the imagine speech is suggested to be the most direct type of communication interface that comes closest to detecting thoughts. ඒ කියන්නේ මේ imagine speech එක most direct type of communication interface. The imagine speech is suggested to be the most direct type of communication interface that comes closest to detecting thoughts. Imagine speech is suggested to be the most direct type of communication interface that comes closest to detecting thoughts. When comes to detecting thoughts, again thoughts කියනවා detect කරද්දී, ඒ කියන්නේ mind waves detect කරද්දී imagine speech is the most closest direct interface. The imagine speech is suggested to be the most direct type of communication interface that comes closest to detecting thoughts. Imagine speech is the most closest direct communication interface. Right. The imagine speech is suggested to be the most direct. It is also endogenous VCA paradigms that does not require an external stimulus. Make a endogenous VCA paradigms. Make it external stimulus. Imagine speech. Point. Imagine speech කියලා කියන්නේ ඒක endogenous එකක්. extragenous නෙවෙයි. extragenous කිව්වම දැන් ඔයාලට මතක් වෙන්න ඕනේ. extragenous වලදී අවශ්‍ය වෙන external stimuli එකක්. හරිද? ඒ කියන්නේ මේ imagine speech එක ගැන තමයි මේ කතා කරමින් සිටියේ. right? මේ තාම අපි යන්නේ මොකද? imagine speech. so මේ imagine speech වලට අදාළව තමයි කතා කරන්නේ. The visual imagery. Then visual imagery කියන කොටසට එනවා. The visual imagery is another active BCI paradigm often used in BCI research. It refers to the emergence of constructive representations and the accompanying perceptual experience without a direct external stimulus. Then visual imagery කියන්නේ external external stimulus එකක් අවශ්‍ය වෙන්නේ නැහැ. ඒක කොහොමද ඒක වැඩ කරන්නේ? Visual imagery is another active BCI paradigm. ඒකත් another active BCI paradigm එකක්. active BCI paradigm එකක්. ඒ කියන්නේ අපි එලින්ම යම් එකක් දිහා බලාගෙන ගන්න එකක් නේ the visual imagery. Visual imagery is another active BCI paradigm often used in BCI research. It refers to the emergence of constructive representatives. It refers to the emergence of constructive representations and the accompanying perceptual experience. Emergence of දැන් මේක මම කොහොමද මම paraphrase කරලා ගන්න. ඉස්සලා ගන්නවා visual imagery කියලා කියන්නේ ඒකත් another active BCI paradigm එකක් which does not need the external stimuli. It refers to the emergence of constructive representation. It refers to the emergence of constructive representations and the accompanying perceptual experience. It refers to the emergence of constructive representations and accompanying ඉතින් මේක මම හදාගමු ඒක emergence constructive representation සහ මේක accompany වෙනවා මොකක් එක්කද accompany වෙන්නේ perceptual experience එකත් එක්ක. එතකොට මම ඔන්න perceptual experience එක කියලා කියන්නේ දැන් අපිට හිතන දැනෙන දේ ගැන මගේ දැක්ම කියන එක මේ visual imagery කියන එක මම තා ගන්නවා. visual imagery. මේකට තේමන් තියෙනවා active PCA paradigm does not need external stimuli. මේක emergence of constructive representations and perceptional experience. It refers to that presence of visual imagery is discovered in මෙයා විසින් ඒක discover කරලා තිනා specifically related to the alpha power changes in the visual cortex. මේක presence of visual imagery depends on the alpha power. Alpha power changes in the visual cortex. In මොලේ තියෙන visual cortex එක කියන එක ඒකේ alpha power changes අනුකූල තමයි මේක. Although the imaging speech and the visual imagery have distinct features in generating protocol and spatial origins in the brain. ඒ වුණාට දැන් මේ imaging speech එකේ සහ visual imagery have distinct features. මේ වගේ වෙන ඒවට අනන්‍ය වෙන features තිබ්බට in generative protocol and spatial origins in the brain, the two paradigms are ambiguously distinguished and indiscriminately used in the previous studies. ඒ කියන්නේ දැන් මේ වගේ මේවට අනන්‍යව තියෙනවනේ මේ imaging speech එකට සහ visual imagery එකට ඒ වුණාට previous studies වලදී මේවා ambiguously ඒ කියන්නේ ඒවා හරියට වටහා ගන්නේ නැතුව මේවා previous studies වලදී use කරලා තියෙනවා. මෙයා suggest කරලා තියෙනවා that brain activity is distinct while observing an imaging scene. Brain activity is distinct while observing an imaging scene. However, and may measure the brain activity of imaging speech while observing a visual cue. Therefore, the acquired data may be interpreted as performing imaging speech. Can suggest that brain activity is distinct while observing and imaging the scene. Brain activity distinct while observing observe කරද්දී සහ imagine කරද්දී ඒක දෙකක් කියන එක. However, may research papers and මේකෙදි measure the brain activity of imaging speech, measure the brain activity of imaging speech while observing a visual cue. දැන් එතකොට මේ research paper එකේදී brain activity of imaging speech එක observe කරලා තියෙනවා, measure කරලා තියෙනවා. may observing a visual cue එකකින් observe කරලා තියෙනවා මේ imaging speech එක. Therefore, the acquired data may be interpreted as performing imaging speech. එතකොට මේ acquired data may be interpreted as දැන් එතකොට මේක acquired data එකකට එයාලා represent කරලා ඇත්තේ imaging speech එකකට, visual imagery or attending to the visual stimuli. Also, the experimental paradigms of previous works is not consistent in terms of procedure or stimuli. Provided an auditory cue before the imaging speech phase. Supplied visual cue during the imaging speech phase. Gave both visual and auditory cue before conducting the imaging speech. In one block, subjects performed 7 times of repeated imaging speech for 1 second in, and the subjects continuously repeated imaging speech for 11 seconds. Visual imagery was performed only once per cue. Hence, there are difficulties in comparing the imaging speech and visual imagery based on previous works. There were previous works only the samahara wage එයාලා imagine space කියන එක measure කරලා තියෙනවා visual එකක් හරි auditory මොකක් හරි pattern එකක් පාවිච්චි කරලා. එතකොට අපි measure කරලා තියෙන එක එයාලා represent කරලා තියෙන්නේ imagine space වෙන්න පුළුවන්. නමුත් ඒ වගේ විතර ඒවා use කරලා තියෙන්නේ visual imagery use කරලා. ඒකට එතන ambiguous තත්ත්වයක් වර්ධනය වෙලා තියෙනවා. Previous studies performed a maximum of 5 class classification of words. ඒ වගේම previous studies will perform maximum of 5 class classification. එහම මෙතන ඔන්න රිසර්ච් ගැප් එක පෙන්වනවා යා. කලින් මේ වගේ කලින් මේ BCA රිසර්චර්ස් කරලා තියෙනවා. නමුත් මේ එයාලා හඳුනාගෙන නැහැ මේ imagine space සහ visual imagery කියලා දෙකක් පිළිබඳව. ඒ දෙකම ඒක මිශ්‍රව තමයි use කරලා තියෙන්නේ. Previous studies performed a maximum of 5 class classification of words and phrases in imaginary space. In the case of visual imaginary, recent research reported that the two visual imaginary classes could not be distinguished from each other. Previous studies will be maximum of 5 class classification of words, phrases in imaginary space 12 use karla tiyenne maximum of 5 class classification eka. In the case of visual imaginary, recent studies reported that the two visual imaginary classes could not be distinguished from each other. Evagem කියනවා researchers වලදී two visual imaginary classes could not be distinguished from each other. However, it is necessary to enlarge the degree of freedom in the two paradigms in order to apply them in the real world communication system. Right. So මෙතන කියලා තියෙන එක අපි ගත්තොත් visual imaginary class reported that two visual imaginary classes could not be distinguished. Visual be distinguished. Each other. However, it is necessary to enlarge the degree of freedom in the two paradigms. Classes in order to apply them in the real world. Right. In this work, inspired by the issues above, we compared the presence and the distinct spatial features of imaging speech and visual imagery using electrode encephalography. In addition, we performed 13 class classification of both paradigms, showing the potential of multi-class classification. Our research leads the following contributions. It was a make a penna dilatina ealage contributions කොහොමද වෙන්නේ කියන එක. එතකොට මතක ඇතුව මේ පොයින්ට් එක මතක වැදගත් වෙනවා. මට රිසර්ච් පේපර් එකක් ලියද්දී මෙයා දැන් අර ඉන්ට්‍රොඩක්ෂන් එක කරගෙන යද්දී ඒ ඉන්ට්‍රොඩක්ෂන් එකේ මැදට ඇවිල්ලා තමන්ගේ contributions ටික දක්වලා තියෙන එක හොඳ පොයින්ට් එකක්. ඒක මෙතෙන්ට අදාළ නැහැ. නමුත් මම ඒක දානවා මේ විදිහට contribution as mentioned in the introduction. Smooth flow. Right. මේ මට යාර රිසර්ච් පේපර් එක ගන්න කරගත්ත ඒක වැදගත්. We classified 13 classes of imaging speech and visual imagery. Our results shows the possibility of discriminating more than දැන් මෙයා කියනවා දැන් මෙයාලගේ මෙතඩ් එක අනිත් ඒ වගේ මෙතඩ් වලින් වෙනස් වෙන්නේ කොහොමද කියලා. මෙයාලා දැන් අර අතන තිබ්බේ 5 class කියලා imagine speech කලින් researchers වල තිබ්බේ 5 class. මෙයාලා 13 classes වලට යනවා. එතකොට අපි දැන් කරනවා නම් එතකොට 13 classes වලට වඩා වැඩි එකක් use කරන්න වෙනවා අපි මේ area එක follow කරනවා නම්. And visual imagery. Our result shows the possibility of discriminating more than 10 classes of words phrases in both imagery paradigms. Our experimental paradigms is strictly divided into the imaging speech and visual imagery in terms of its definition. මෙයාලගේ experimental paradigm එක strictly divide කරලා තියෙන imaging speech සහ visual imagery කරලා ඊට පස්සේ according to definition the results confirms the presence of two paradigms and its spatial feature. To the best of our knowledge මේ වචන පාවිච්චි කරන්න ඕනේ. To best of our knowledge කියලා කිව්වම එයාලා දන්න විදිහට එතකොට දැන් මේකදී fully funded එකට යද්දි මේ ඔයාලා දන්න විදිහ කියන එක වැඩක් නෑ. එයාලට අවශ්‍ය හොඳ research should not use this word. ඒ කියන්නේ ඔයාලගේ research එක ඒක maximum තත්ත්වය තියෙන්න ඕන. To best of our knowledge ඒ වගේ වචන පාවිච්චි කරන්න එපා. To best of our knowledge a data set of imaging speech and visual imagery performed by identical subject hasn't been reported. Imaging speech and visual imagery performed by identical subject hasn't been reported. However, comparison and distinction between the two paradigms can give rise to the appropriate use of them. A data set of imaging speech of visual imagery performed by identical subject hasn't been reported. A data set of imaging speech and visual imagery performed by identical subject. Again, identical subject එකේ අනන්‍ය වෙච්ච imaging speech or visual imagery performed identical subject hasn't been reported. ඒතර මෙයාලා ඒ අනන්‍යව ඒ කියන්නේ ඒකට යුනික් වෙන විදිහට visual imagery සහ imaging speech වලට යුනික් වෙන data set එකක් create කරගන්න. However, comparison and distinction between the two paradigms can give rise to the appropriate use of them, leading to robust and intuitive decoding of user intention. Our findings could support the potential of an adaptable usage of the two paradigms. Therefore, we aim at suggesting the possible form of a real-world communication system in the near future. දැන් ඔන්න මෙතන ඔන්න අපිට ඔන්න එකක් දෙනවා දැන් මෙයාලා therefore we aim at suggesting the possible form of a real-world communication system in the near future. ඉස්සරහට එයාලා suggest කරනවා ඔය imaging speech මත පදනම් වෙච්ච unique or visual imagery මත පදනම් වෙච්ච unique real world communication system. නමුත් තාම ඒක කරලා නැතිවීම අපිට වාස්දායක අපිට අලුත් research එකකට යන්න තියෙන තැනක් ඒක. මෙතන research gap එකක් තියෙනවා. මම මේ research paper එකකින් හොයනගත්ත research gap එකක් තියෙනවා. right? Research gap communication system based on identical imaging speech or visual image. It is materials and methods of the materials and methods of the subjects the 7 healthy subjects with no history of neurological disease were recruited. Then materials and methods at the methods of follow researchers let's use කරපු ඒවා ඒ වගේ ඇරලා තියෙනවා යම් මෙතෙට් එක ඊට වඩා හොඳ ඕ ඒ හා සමානව අපි use වෙන්න ඕන. Subjects again procedure 7 healthy subjects with no history of neurological disease were recruited for the experiment. 6 males mean age එක දීලා තියෙනවා මේ විදිහට plus or minus 1.13 range එක 23 to 26 වයස් පරතරය match ප්‍රමාණය. ඒතර මේ වගේ detail වෙන්න ඕනේ. Every subject was right-handed and well educated in English for more than 15 years. Subject had no visual, hearing or motor impairments and abstained from any drug or alcohol in the 12 hours before the session time. The study was carried out in accordance with the Declaration of Helsinki. University of Helsinki again, in Finland, University. ඒකෙන් තියෙන මෙයාලා මේ ඩෙක්ලරේෂන් එකක් තියෙනවා. ඒ ඩෙක්ලරේෂන් එකට මෙයාලා සයින් කළා තමයි මෙයාලා මේ එක්ස්පෙරිමන්ට් එකට භාජනය වෙන්නේ මේ කට්ටිය සබ්ජෙක්ට්ස් ලා. The experimental protocols were reviewed and approved by the institution's review board at Korea University. All subjects signed informed consent. Experimental setup එක කොහොමද අපි experimental setup එක ගන්නෙ? එතකොට මෙතන තියෙනවා දැන් materials and methods වලින් මම භාජනය කරන්න ඕන දෙයක් මට දැනගන්නට අවශ්‍යයි. මට research එක plan කරන්න materials and methods වලදී මේකත් මම මේ මගේ අවධානය සඳහා මම ඉස්සරහ research මගේ paper එක ලියද්දී මම තාම literature review එකේ paper එක ලියද්දී මට මේවා plan කරන විදිහ වැදගත්. ඒකට ආයෙ බලන්න ඕනේ නැහැ. ඒකට මේකේ එක දෙයක් තමයි මෙයාලා ගත්තේ subjects කියලා topic එකකට තේ subjects ලා ගැන විස්තරය ගියා. ඒතර ඒ subjects වල description එක ගියා. ඊට පස්සේ මෙතන දාලා තියෙන experimental setup එක. ඊට පස්සේ ඒක මට වැදගත් experimental setup එක. ඊට පස්සේ correct small distraction. It was a experimental paradigm and stimuli එක ඊට පස්සේ experimental paradigm ස්පෙලිං පස්සේ හදමු. ඊට පස්සේ තියෙනවා D ඊට පස්සේ මෙතන data analysis එක ගැන එක වෙනම විදිහට යන්නේ. ඒකත් materials and methods වලට යන්නේ. data analysis එක ඊට පස්සේ statistical analysis එක results වෙනවා. data analysis එවගේම statistical analysis. data analysis, statistical, right? මට materials methods ටික වැදගත්. දැන් මම අලුත් මේ research එකක් කරන්නේ. ඒතර මේ මෙයාලා ඒ පාවිච්චි කරපු format එකක් තියෙනනේ. format එක මම ඉගෙන ගන්න දේ තමයි ඕක, right? එන්න මම ඒක අධ්‍යයනය කරනවා. ඒ subjects ගැන මම කතා කරා. ඊට පස්සේ මේ experimental setup කියන එකට ගියොත් the subject sat on an armchair observing LCD monitor. මේ කියන්නේ subjects ලා armchair එක ඉඳගෙන observing LCD monitor screen එක දිහා බලන්නේ. A speaker was set besides for providing an auditory cue. දැන් කතා කරන එක්කෙනා was set beside for providing an auditory cue. auditory cue එකක් ලබා දෙනවා. 64 channel EEG cap with active silver chloride electrodes placement following the international 10 to 20 systems were used for the recording. එතකොට මේ 64 channel EEG device එකක් use කරලා ඒකේ තියෙනවා silver chloride electrodes. ඊට පස්සේ මේකට use කරනවා 10 to 20 international system එක. ඒ system එකට අනුකූලව තමයි මේ placements වෙන electrodes. FCZ and FPZ channels were used as a reference and ground electrodes. දැන් මේ අර අපි experimental එකේදී අපේ අර use කරන channel එකේ සහ අපේ paradigm එක පොඩ්ඩක් මෙතන විස්තර වෙනවා. respectively. All impedances of the electrodes were maintained below 10 kilo ohm during the experiment. ඒගන full detail එකක් ලබා දෙන්නට ඕනේ අපි කොහොමද experimental එක set කරේ කියන එක. EEG signals were collected at a sampling rate of 1000 hertz where brain vision recorded. It was during the experiment. EEG signals were collected at the sampling rate of 1000 hertz where brain vision recorded. Brain product Germany and operated MATLAB 2018 A software. तो मैं use करपु software से ऐटिका कुमा अतने विस्तार करना थी. तो stimulator के गया हम stimulating के ना 12 words phrases ambulance ते मैं use कर लेते हैं word phrases ambulance clock hello help me light pain stop thank you toilet TV water and yes that are commonly used for patients were selected from a communication board. The communication board words use board widely used in the worldwide hospitals for paralyzed aphasia patients. I make use paralyzed patients let a useful the communication board use the words can be used to provide an external vocabulary for the patient's communication. We chose not only the words that are frequently used in VCA system, but also general words to be used in the real world. Therefore, we investigated the possibility of expanding the VCA system onto the real world for various purposes. Again, Meala VCA system will generally use for words with samanya real world use system expand real world various purposes. It was the experimental consists of two different sessions. The subject performed imaging speech in session 1. The experimental consists of two different sessions. Sessions session 1 the subject performed imaging speech in session 1 and the visual imagery in session 2. Each session was performed on 2 different days. මේ දෙක දවස් දෙකකදී මේ session දවස් දෙකකදී තමයි කරන්නේ 2 different days in order to avoid interference between session. මේ session අතර interference එක වළක්වන්න තමයි ඒක දවස් දෙකකදී use කරලා තියෙන්නේ. 22 blocks of 22 blocks of 12 words and rest class total of 286 blocks were randomly presented per each session. In each block auditory, imaging speech, or visual cue. Auditory imaging speech or visual cue, visual imagery was first presented for 2 seconds, following by 0.8 to 1.2 seconds of a cross mark. Then the cross mark disappears, leaving blank screen remaining for 2 seconds. The subjects were instructed to perform the given task as soon as cross mark disappeared on the screen. The subject were instructed to perform the given task as soon as the cross mark disappeared on the screen. After 2 seconds, the task performed time, the cross mark again appeared on the screen for 0.8 to 1.2 seconds, followed by 2 seconds of a black screen. Subjects were to perform 4 trials of the given cue, each block followed by 3 seconds of relaxed space to clear up the mind of the next one. Therefore, 80 trials per class, a total of this much of 144 trials were recorded by each subject per session. Trials record කරලා තියෙනවා. මේකට ඒක මේ දීලා තියෙන මෙන්න session 1 එක session 2 එක ඒ ගැන idea එකක් ගන්න මොකද මම කරන්නේ මම මේක snipple tool එකෙන් අරගන්නවා මේකත් එක්ක බලන්න ඒකේ experimental setup එකේ යන්න මට මේක බලුවම මට ඒ ගැන රිසර්ච් පේපර් එක අයිඩියා එකක් ගන්න. ඒකට ඒ ටික හරියට ඇස්සේ ඊට data analysis එකට යනවා. Right. Data analysis එකේදී the data were band pass filters to the frequency range of 0.5 to 40 hertz. The data were band pass filtered. The data were band pass filtered to the frequency range of 0.5 to 40 hertz using a fifth order Butterworth filter. The EG signals were segmented into two second sequence from the beginning of each trial. Baseline correction was performed by subtracting the average value of 200 milliseconds before the trial onset. And මම මේක කතා කරගෙන යද්දි මුලින්ම මට උන් ප්‍රශ්නයක් වෙනවා මොකද මේ band passed filtered ඒ වගේම මේ 0.5 මේ ඒ වගේම Butterworth filter ඔන්න ගැන idea එකක් දැන් මට නැහැ මම මේකම අරගෙන මම මේක මොකක්ද මේ කියන එක ගැන idea එක දෙන්නට දාගන්නට මම මෙතන මේක italic කරලා තියාගන්නවා මේක data analysis එකට දාලා data analysis එකේ data analysis මේක italic කරත් මම දන්නවා මේක මට දෙයක් මේක මොකක්ද මේ කියන්නේ කියන එක අධ්‍යයනය කරන්න අවශ්‍යයි. Right. LP performed a binary classification of imaging phase versus rest to identify the presence of imaging speech. Then මම දැන් බෑග් ගිහිලා තිනවා මේක අධ්‍යයනය කරනවා. ඒක මගේ කාසිමාව මම යනවා මට දැනෙනවා මේක සෑහෙන ඉෆෙක්ටිව් විදිහට මම මේක ස්ටඩි කරගෙන යන්නේ ඒ නිසා මම මේක වෙනස් කරන්න නැතුව ඔය විදිහට යනවා මම බැලුවොත් එහෙනම් දැන් මට ඉස්සරහට තියෙද්දි මේ ටික තමයි අධ්‍යයනය කරන්න තියෙන්නේ. ඒතර මේ දක්වා දැන් මට ටැග් ගාලා යන්න පුළුවන්. විනාඩි 10කින් විතර මට අවසන් කරගන්න හැකියාව තියෙනවා. We perform binary classification of imaginary phase versus rest to identify the presence of imaging phase and visual imagery. Only the first imaginary trials in every block we binary classification එකක් තියෙනවා. Imaginary phase versus rest to identify the presence of imaging speech and visual imagery. මේකත් අපි ගමු. කරපු දේ ටාස්ක් එක ඉවත් දාගන්න. binary classification එකක් කරලා තියෙනවා. ඒ data analysis වල කරපු දෙයක් මෙතන. ඊපස්සේ only the first imaginary trials to every block was selected to set equal classes ratio for comparing the classes. The binary classification groups of the imaging merge tasks and attending to stimuli merge tasks versus rest were set based on the external stimuli of the binary classification for auditory stimuli for the imaging speech sessions and visual stimuli for the visual. Only the first imaginary trials in every block were selected. Only the first imaginary trial in every block were selected to set an equal class ratio for comparing the classes. First block first trial first imaginary trials in every block were selected to set equal class ratio. Equal class ratio the binary classification groups of the imaging merged task and attending to stimuli merged task versus rest was set based on the external stimuli of the binary classification were auditory stimuli for the imaging speech session. External stimuli of the binary classification were auditory stimuli for the imaging speech session and visual stimuli for the visual imaging session. The channel selection was performed to compare and confirm the relevant brain regions of imaging speech and visual imaging. CS1 consists of Broca and Wernicke area and left may regions. a data got the regions in the binary classification. We used spatial frequency feature based on common spatial pattern CSP. CSP is a feature extraction method, highly predictive for most users. Feature extraction method use common spatial pattern common spatial pattern we used a spatial frequency feature based on a common spatial pattern. CSP is a feature extraction method, highly predictive for most users. Right. Classification was performed by the shrinkage regularized linear discrimination analysis. It was a classification use algorithm sticker. Classification was performed by the shrinkage regularized linear discrimination analysis. The shrinkage RLDA is a classification method adding regularization term to a convariance matrix using optimal shrinkage parameter. මොකද මෙතනින් මට රිසර්ච් ගැප් එක ගැන අයිඩියා එකක් දෙන්න පුළුවන් යාළුවගේ data analysis part එකකින්. 13 class words make use color classification. Imaging speech and visual imaging were performed in order to investigate the possibility of multi-class classification. We used every 88 trials, a total of by Pramania, performed used based on CSP, one versus rest strategy. CSP is a keyword method for binary classification. The RF was applied to compare the classification accuracy with the shrinkage RLDA. Since RF is RF random forest RLDA random forest and then make a mocha to the make again 13 class and 12 classes classification of imaging speech and visual imagery were performed in order to investigate the possibility multi-class. So we used every 88 trials to feature extraction of basic separating each class was used for multi-class classification. Imaging faced versus people presence of then methanoli make a kila it was a the binary classification use make a methanaya kila ikam katawa neda kiya in the binary classification used මේ කතාව මෙතන කියලා ආයෙ මෙතෙන් තාමත් ඒ කතාව යලි කියනවා additional කියනවා මෙතන besides the RF random forest random forest RF is known as a robust classification RF විදාගත්ත කියන මෙතන right. It is furthermore we performed an additional binary classification of two imaginary classes. It was additional binary classification use ambulance and toilet for visual imaginations. Right. Take classifications kata overall it was a 13 classes it was additional 2 classes use besides the channel selections besides the channel selection part, all channels were used in the analysis to compare the classification accuracy of image installation visual imagery in the same condition. For all classification 10-fold cross validation was performed. This method is performed by randomly dividing all the trials of each subject into 10 equal sized subjects and classified 10 times using the 9 subjects as a training sets and 1 subject as a test maker. But the tenfold cross validation was performed. මේවා එයාලගේ data analysis වලදී use කරපු method. The statistical analysis of the GAMA, we perform statistical analysis on the classification result in order to estimate the significance of our result. Friedman test non-parametric of two-way analysis of variance was performed 2 paradigms into 2 classification groups in comparing the intensity of imaging speech and visual imagery compared to the rest. For the comparison of the 2 channel selection groups, non-parameters of bootstrap analysis with Bonferroni correction was applied. We also performed Friedman test. Friedman test again use to compare 13 class classification accuracy performed by string cage RLDA and RF. The non-parametric bootstrap analysis with Bonferroni correction was applied as a post hoc analysis. It was a statistical analysis. Statistical analysis වල මේ යොදාගෙන තියෙන Friedman test ඒ මොනවද කියන එක දැනගන්න අපිට ඉස්සරහට ස්ටඩි කරන්න වෙනවා. මොකද රිසර්ච් පේපර් එකකින් ඒවා ඒ වගේ අර overview එකක් විතරයි දෙන්නේ. No statistical analysis, the significance level was set at alpha equals 0.05. Also, the significance for the classification accuracy compared to the chance level was analyzed according to the Mueller-Birds the 95% confidence boundary considered the chance level at the number of it is a statistical analysis. That's the results that the presence of imaging speech and visual imagery, the average accuracy of tenfold classification of 2 classification groups attending to external stimuli versus rest and performing mental imagery versus rest in each session is presented in table 1. The average classification accuracy of attending stimuli or performing mental imagery versus rest in every group exceeded the confidence bound 64%, 22 trials per class. The average accuracy of tenfold accuracy of 2 classification groups attending to මේක බලන්න සිතන දෙන්නට ඕන උපදෙස් තමයි මේ ආකාරයෙන් තමයි අපි රිසර්ච් පේපර් එකක් රීඩ් කරන්නට ඕනේ කියන එක අනේක බලන්න. මොකද රිසර්ච් පේපර් එකක් කියවන්න නැතුව නිකන් තියෙන YouTube වීඩියෝස් බලාගෙන රිසර්ච් කරන කට්ටිය ඉන්නවා. එහෙම කරලා එහෙම රිසර්ච් ලෝකෙට ප්‍රවිෂ්ඨ වෙන්න බෑ. මේක මේවා thoroughly read කරන්න ඕනේ. සාමාන්‍යයෙන් USA UK වගේ රටවල කට්ටිය සෑහෙන දේවල් රිෆර් කරලා අධ්‍යයනය කරලා තමයි මේ රිසර්ච් වර්ල්ඩ් එකට ප්‍රවේශ වෙන්නේ. Right, it is about the results of the presence of imaging, speech and visual imagery. The average accuracy of tenfold classification of 2 classification groups attending to external stimuli versus rest and performing mental imagery versus rest in each session is presented in table 1. The average classification accuracy of attending to stimuli or performing mental imagery versus rest in every group exceeded the coefficient confidence bound. Does a result showing the presence of imaging, speech and visual imagery? මම මේක පොඩි අයිඩියා එකක් ගන්න හිතාගත්තොත් අවශ්‍යයි. Attendant to stimulate the stress. මොකද මගේ ඉස්සරහ papers වලදී මම ඒ papers සකස් කරද්දී එන්නේ table ගැන එහෙම අයිඩියා එක ගන්නට මට හිතෙන මේක දාගත්තොත් හොඳයි කියන එක. මේක මම පහළට ගිහිල්ලා මේක හදාගන්න. let's see ගොඩක් තියෙනවා. right ඊට පස්සේ අපි ගියොත් එහෙම දැන් මේකෙත් ඊට පස්සේ table to classification accuracy එක ඊට පස්සේ classification accuracy එක මෙතන දාලා තියෙනකොට මේකත් classification accuracy එක cross validation මේක අවශ්‍ය නැහැ. ඒකට we compare the intensity of imagery in the imaging speech and visual imagery by statistical analysis of the binary classification accuracy of imaginary face versus rest. The imaging speech versus rest and the visual imagery versus rest did not show a significant difference in the classification accuracy. Also, there wasn't a significant difference in classification performance between auditory stimuli versus rest and visual stimuli versus rest. The binary imagery versus rest classification result of each general selection groups is shown in table 2. The classification accuracy of the imaging speech shows significant degradation CS2 compared to CS1. Also in visual imagery, the classification performance decreased significantly in CS1 compared to CS2. Multi-class classification accuracy. And the third class, well, the multi-class accuracy, එක වගේ ගත්ත accuracy දක්වලා තියෙන ඊට පස්සේ මේ මොකක්ද classification accuracy එක දක්වලා තියෙන එක subject එකට අනුකූලව ඒක දක්වලා තියෙන ඊට පස්සේ imaging speech visual imagery එකේ confusion matrix එක දක්වලා තියෙනවා. ඊට discussion එක ගත්තොත් the classifier could distinguish between the attendant to stimuli or performing mental imagery from rest condition in both imaging. The classifier could distinguish between attending to stimuli or performing mental imagery from rest condition in both imaging speech and visual imagery session, showing the presence of imaging speech as well as visual imagery. The result is consistent with research in terms of the presence of visual imagery. Although the imaging speech and visual imagery were both present, the intensity of the imagery in the imaging speech and the visual imagery did not have a significant, although the imaging speech and visual imagery were both present. Present the intensity of the imagery in the imaging speech and the visual imagery did not have any significant disparity between each other. Therefore, we concluded that the mental imagery of either the imaging speech or visual imagery is not stronger than the other. මේක තව දෙකක් concept එකක් යාළුවගේ conclusion එකේ discussion එකේ ගන්න එක although the imaging speech ඒක එහෙම නෙවෙයි මේ copy කරලා ගත්තොත් මම එහෙම again visual although the imaging speech and visual imagery were both present but dekama present වුණාට the intensity of the imagery in the imaging speech and the visual imagery did not have any significant disparity between each other. ඒ වගේ significant disparity එකක් නැහැ. Therefore we concluded that the mental imagery of either the imaging speech or visual imagery is not stronger than the other. Both paradigms have the potential to be employed in the PCA communication system when performed properly. The channel selection was performed in the binary classification of performing imaginary versus resting order to further compare the relevant brain region of imagined speech. The channel selection was performed in the binary classification of performed imaginary versus resting order to further compare the relevant brain region of imagined speech and visual imagery. Our result was in line with the neural representation discovered in previous works. The neural representation for imagined speech is also known as the delta and alpha bands in the temporal lobe, frontal lobe, and the sensorimeter cortex, so-called Broca's and Van area also it reported. Now we're comparing the classification accuracy by selecting. The result confirms that the relevant regions of the imagined speech and the visual imagery confirms the relevant region of the image. Also, it implies that if the user obscurely performs the imagined speech or visual imagery, it is unreliable to select a small number of channels from the relevant area for the best classification performed. Therefore, it is important to clearly distinguish the paradigms that the user perform, that the selection channels from the pertinent area in the application. In addition, the higher classification accuracy shown in the relevant area of each paradigms indicates that the experimental paradigms has properly measured the precise mental imagery or imagined speech and visual imagery. The multi-class classification accuracy of imagined speech in the previous works was 5 class 32.9 අපි ගත්ත results දක්වා තියෙන previous way වගේ robust classification. Although there were many classes, our results showed robust classification accuracy, showing the possibility of multi-class classification of imagined speech to be applied in the intuitive communication system. We consider our result is due to the experimental paradigm of repeating 4 times of imaginary task in one cue. Therefore, the subjects may have performed a coherent imagination. The experimental paradigm of Mega repeated the imagined speech 7 times per one cue, and they also show robust classification performance. On the other hand, the previous works on visual imagery failed in discriminating between 2 different visual imagery classes for classification accuracy of discriminating between 2 visual imagery tasks. However, according to our results, the classifier could discriminate between the 2 imagery classes. The different results with Maker may be due to the different word choice. We could interpret the result that words we chose being more distinct from the Maker compared to result again distinct කරගන්න පුළුවන් වුණා imagined speech and the visual imagery. Conclusion: in the study, we demonstrated the possibility of applying the imagined speech and visual imagery in the real-world communication system. In the study, we demonstrated the possibility of applying imagined speech and visual imagery in the real-world communication system. We strictly divided the 2 paradigms and compared them in terms of their presence and spatial origins. Our results show the possibility of robust classification of more than 10 classes of imagined speech and visual imagery. Our findings could be a milestone to intuitive BCS communication system. Further investigations in a robust classification method would enlarge the degree of freedom and improve the performance, therefore lead to the practical use of them in the real world. Our dataset would provide a significant materials in further analysis in the 2 paradigms, imagined speech and visual imagery, directly include the use intention itself. Therefore, the use intention can be directly conveyed without any stimuli or display equipment. It can bring up extreme convenience and intuitiveness of BCA communication. Furthermore, use intention can be decoded in the word or phrase until unit when using imagined speech or visual imagery. It can be more efficient than the conventional speller systems that enter by letter. This intuitive BCA communication system can be further be applied in the artificial intelligence speakers, enabling the speaker to speak out the user's thought by just imagining the very thing that the user wants to speak out. Acknowledgement එක දීලා තියෙනවා මෙයාලට. Right, it was the research paper එක ඉවරයි. දැන් මේකෙදි මෙයාලා ඔන්න distinguish කරලා තියෙනවා මේ but imaginary speech එක සහ මේ visual imagery එක ඊට පස්සේ suggest කරලා තියෙනවා හොඳ intuitive BCI communication system එකක් ඉස්සරහට සකස් කරගන්නීමට මේක තවදුරටත් වැඩි දියුණු කරන්න. නමුත් එහෙම application එකක් develop කරලා නැහැ. අන්නේ ඒක අපිට හොඳ research gap එකක් අපිට මේ විදිහට application එකක් develop කරන්නට පුළුවන්. ඒතර imagine speech මෙයාලගේ ඔය මේ කියපු ඒ research එක මත පදනම් වෙලා අපිට පුළුවන් අවශ්‍ය නම් අපිට application එකක් develop කරන්න. Right, ඒකට මට ලැබිච්ච කාලය මම සාමාන්‍යයෙන් පැය එකයි විනාඩි කාලයකින් ඒක ඉවර කරා. ඒතර මේක අර කලින් එකට වඩා efficient. ඒතර කලින් එකේදී වාක්‍යයේ පිටු 30ක් තිබ්බ කියලා. ඒ පිටු 30ක් කියලා කියන්නේ මේ අර මේක one side නේ මේ විදිහට තමයි තියෙන්නේ. Right. Right. Okay, that's the research paper එක finish කරපු ආකාරය. නමුත් අපේ දැන් continuity එක තියෙනට ඕනේ දිගටම 12:00 වෙනකන් අපේ මේ session එක යනවා. දැන් මම ඒකේදී දැන් ගත්ත data ටික තියෙනවා. මේ මගේ මොකක්ද research paper 2 වලට අදාළව මම ගහගත්ත දේවල් ටික. ඊට මේක දැන් මම research paper 2 එක දාගන්නවා මගේ අර අලුතෙන් හදාගත්ත R2 කියන එකට නේ R1 නේද? R1ද මොකක්ද? කොහෙද? මේක මම send කරනවා. move item add to collection again and reviewed R1 reviewed R1 එකට ගියොත් එහෙම මේකේ වෙන දැන් දෙකක් මම review කරලා තියෙනවා. දැන් නේද? මේකේදී ලොකු දෙයක් කරගන්න අවශ්‍යතාවයක් නැහැ. ඒක අවශ්‍ය නැහැ. දැන් මම අනේ papers දෙකක් බලලා තියෙනවා. තව මට papers බලන්නට අවශ්‍යයි. මේක තනිකර ඉස්සෙල්ලම papers බලන්න නඳපවක. ඊට පස්සේ මම direction එකේ තව එකකට එන්න ගැන දෙගත්ත කියන එක මේක ගත්තොත් මේක වැදගත් වෙන එක බලමු මේ නෑ මේක වැදගත්කමක් තියෙන්නේ නැහැ. ඒකට ඒක වැදගත්කමක් නෑ. ඊට මේක එකම වැදගත්කමක් නෑ කියලා තේරෙන නිසා මොකද මම ඒක තියාගන්නේ. ඒක කරන්න බැරිද ඒක? assume yes කරා. ඊට මේක low cost semi-autonomous wheelchair controlled by remote imagery and jaw muscle activation. ඒක අවශ්‍ය වේවි. ඒ කියන්නේ මම ඔන්න තුන්වෙනි එක ගන්න ස්ටඩි කරන්න යන්නේ. දැන් කලින්ට වඩා efficient වෙනවා. දැන් පැය එකක කාලයක් ගියා. දැන් පටන් ගන්න ටයිම් එකම 9:41යි. දැන් බලමු. පැය එකක කාලයක පැයකින් වගේ කරගෙන පුළුවන්. හොඳයි. ඒක R3 කියලා දානවා. R3 topic එක දැම්මා. මේක highlight කරලා lock කරේ. එන්න දැන් යනවා. දැන් ගන්න කලින්ට වඩා efficient වෙනවා. ඒක තුන පහළට දාගන්න. මේ මගේ complete literature review. ඊට පස්සේ මම මේවා මේ ගත්ත දේවා දැන් මේවා මගේ එන්නේ මේකේ සම්පූර්ණයෙන්ගේ site එක වදින්නේ 3 කියලා. right? Abstract එක කියවොත් wheelchairs controlled using electroencephalography have been proposed to facilitate independent mobility for people with motor disabilities. Wheelchairs controlled using electroencephalography have been proposed to. මේක කියවලා මම ඒක සමරයිස් කරගන්නවා. නෑ මම හිමින් කියවන්නම්. ඒතර මුමුණන silent speech එක තියෙන. ඒකෙන් එන එක හොඳයි. මම මේ වැඩේ කරන්න ගත්තම මම සෑහෙන වතුර බොනවා. ඒක හොඳ සෞඛ්‍යමය තත්ත්වයක්. වෙනද ඇත්තට වතුර බොන්නේ නැහැ. ඒක ශාරීරික ක්‍රියාවලියත් ඉතාම හොඳට සිද්ධ වෙනවා. අනිත් එක අතර තියෙන වටිනාම දේ මේක දැන් ඔය කියවන්නට එපැහි වෙනවනේ. එතකොට ඒක අකණ්ඩව යනවා. ඒක ලොකු දෙයක්. නැත්නම් ඉතින් ඔක යන්නේ බොරුව. Right. Wheelchairs controlled using electroencephalography. again wheelchair එකක් මේ EG signals වලින් control කරන එක පිළිබඳව තමයි මේ කියන්නේ. Wheelchairs controlled using electroencephalography have been proposed to facilitate independent mobility for people with motor disabilities. To date, the majority of these systems have relied on distracting external stimuli such as flashing lights and expensive medical-grade EEG amplifiers. We propose a wheelchair prototype that uses a band and uses hand motor imagery and jaw clench data collected with the consumer grade EEG system to generate left, right, forward, and stop commands. The signal is classified with logistic regression and using only 2 scarp electrodes and a 2-second window size. We obtained a mean subject accuracy of 60 plus or minus 5 and a peak subject accuracy of 82 plus or minus 3%. We introduced a novel control flow paradigms relying on an intermediate control state engaged by jaw clenching to reduce the complexity of our classification problem, as well as real-time spectrograms for neurofeedback training. Additionally, we supplement our system with automated driving features, a location tracker, and a heart rate monitor to increase the usability and safety. Then wheelchairs use කරන්නට AG based wheelchairs තියෙනවා. නමුත් ඒවට ගොඩක් වෙලාවට ඔය SSPP තමයි use කරන්නේ. right? අනිත් idea එක ගන්න දැන් මෙයාලා හදලා තියෙනවා මේකෙදි හදලා තියෙන එකේ ටෙක්නික් එක වෙන්නේ මෙයාලා propose කරලා තියෙන prototype එකක් ඒක use කරලා තියෙන hand motor imagery and jaw clench data collected with the consumer grade EEG system. ඒක මගින් left, right, forward and stop commands වලට පාවිච්චි කරන්න පුළුවන්. The signal is classified with logistic regression. එයාලගේ method එක. එතකොට මේක තමයි එයාලගේ concept එක වෙන්නේ. හරිද? We propose and using only 2 scarp electrodes. ඒ වගේම මේක පොඩි electrodes වල තියෙන්නේ. ඒතර මේකේ වේදනක් අඩුයි. දැන් මම මේකේ idea එක ගත්තා. මට ඒක වැඩි ලියන්න දෙයක් නැහැ abstract එකට. abstract එක කියලා දාලා මම idea එක ගත්තා. ඒක ඊට පස්සේ right. ඊට පස්සේ introduction with the brain computer interface have emerged as a technology that enables patients with motor deficits caused by spinal cord injuries or neurodegenerative diseases to interact with external world. PCA use karna have emerged as a technology that enables patients with motor deficits caused by spinal cord injuries or neurodegenerative diseases to interact with the external world. BCA ඇවිල්ලා තියෙන neuro සහ මේ motor deficits තියෙන පුද්ගලයන්ට external world එකත් එක්ක communicate කරන්න interact with. Specifically electroencephalography based BCA relying on motor imagery have high translational potential. Translational potential as they are non-invasive, portable, and do not depend on the external stimuli. අපිට කියන්න specifically electroencephalography relying on motor imaging. Motor imagery කියන එකේදී external stimuli එකක් මොකද depend වෙන්නේ නැහැ. ඒක හොඳ තත්ත්වයක්. Electroencephalography based BCA system relies on motor imagery have high translational potential as they are non-invasive, portable, and do not depend on external stimuli. External stimuli එකක් මත රඳා උපවතීම කියන සාධකය මත මට මේකේ තාම මේ introduction එකේදී මට ගන්න පුළුවන් එක point එකක් වෙන්නේ ඒ වාසිදායක තත්ත්වයක් එනවා ඔය first කියලා දාලා මේක විතර copy paste කරලා දක්වන්න. ඒක ගන්න මම ඒක ඔළුවම දාගත්තා. ඊට පස්සේ මම ඒක අතින් paraphrase කරන්නේ නැහැ. මේක මම ඒ idea එක දාගත්තා. ඒතර ගන්න research paper එකට ගනිත් මේක මම paraphrase කරලා දාගන්න. MI refers to the use of imagined movement. Imagined motor imaging refers to the use of imagined movement to generate an EEG signals that serves as a command for the BCA. Use of imagined movement. Motor imaging can image movement to generate an EEG signals that serves as a command for the BCA. This paradigm requires suppression of power or event-related desynchronization that serves as a command for BCA. This paradigm requires a suppression of power or event-related desynchronization of the mu rhythm 8 to 12 in the sensorimotor cortical region associated with imaging movement of a given muscle. එතකොට මේ imaging motor imaging refers to the use of imaging movement to generate an EEG signal that serves as a command for the BCA. This paradigm requires a suppression of power event-related desynchronization. මේ motor imaginary paradigm එකේ require වෙනවා suppression of power or event-related desynchronization. The motor imaginary එකේදී desynchronization එකක් වෙනවා event-related of the mu rhythm, right? Make up event desynchronization of mu rhythm 8 to 12 in the sensorimotor cortical region associated with imaging movement of a given muscle. දැන් මේ ඒකෙදි use වෙනවා කියලා කියන ERD. ඒ කියන්නේ මේ imaging speech එකේදී use වෙන දේ. මේක මම කලින් research paper වල දැක්ක තත්ත්වයක් නෙවෙයි. සමග ඒකට දාගත්තා. On-demand generation of robust MI is challenging. On-demand generation of robust MI is challenging. Untrained individuals typically visualize movements instead of imaging. They are untrained කරපු individuals, again subjects that එයාලා visualize කරන movements instead of imaging the kinds that it experiences associated with movement, which has been shown to result in more accurate MI-based BCA control. On-demand generation of robust MI is challenging. Untrained individuals typically visualize movement. Untrained individuals typically visualize movement instead of imaging the kinesthetic experiences associated with the movement, which has been shown to result in more accurate MI-based visual control, neurofeedback training, which presents individuals with a real-time assessment of the quality of their MI. They serve to resolve this issue, uh, may serve to resolve this issue and increase accuracy. On-demand generation of robust MI is challenging. Untrained individuals typically untrained trained individuals typically visualize movement. Movement visualize visualize movements instead of imagine the kinesthetic experience. May movement visualize instead of kinesthetic experience. A kinesthetic experience which has been shown to result in more accurate experience imagine movement visualize on the accuracy neurofeedback training, which presents individuals with a real-time assessments of the quality of their MI, may serve to resolve the issue and increase the accuracy. Numerous methods have been developed to control electric wheelchairs using MI. The simplest consists of detecting potential trajectories in the environment and relying on user-generated MI to toggle between the computer trajectories. While this approach yields reasonable accuracy greater than 80%, it restricts the freedom of the user to set off automatically determined trajectories. More complex control schemes, such as use MI to toggle between commands right, left, forward, reverse, stop, rather than between paths achieving 72% accuracy. Or use hybrid systems that combine MI with other EEG signals, such as P300 event-related potential, which relies on users focusing on flashing images on a screen. P300 approaches are not suitable for real-world applications as they require users to remain focused on the screen rather than on the environment. In addition, these studies use medical-grade EEG amplifiers, which are expensive and inaccessible to the general public. The use of more affordable consumer-grade EEG systems to develop MI-controlled wheelchairs is not widely studied. And examples which use different biosignals are more common. And examples which use different biosignals are more common. Using low-cost hardware, one group measured saccades to blink toggle between auditory commands, achieving 97% classification accuracy with only 2 electrodes, and another used flashing lights and steady-state visual potentials to control wheelchair navigation with 79% accuracy. To our knowledge, no groups have used MI data collected from a consumer-grade EEG system to control a wheelchair. And the highest MI classification accuracy with low-cost hardware is 83% using 8 EEG signal channels and a 5 seconds time window. We improve upon the previous work with the mind control locomotive, MILO, upon this previous work with the mind control locomotive, a motorized wheelchair that uses a consumer-grade EEG and self-driving technology to perform real-time neural decoding and navigation in realistic indoor environments. In our aim to increase usability by using minimal decision time, window, and number of electrodes, we design a control system that not only uses MI but employs the much stronger electromyographic signals produced by muscle artifacts. Visual neurofeedback is leveraged to assist users in the challenging task of generating MI to is leveraged to assist users in the challenging task of generating MI to control the wheelchair. To demonstrate feasibility, we performed decoding experiments on right and left MI in a small pilot group of able-bodied participants. Additionally, several automatic driving features are implemented to ensure safe and easy user operation, including automatic following, obstacle avoidance, fall prevention, and user distress monitoring. Methodology that the Milo implements a novel user interface to allow its user Milo again. We improve upon this previous work with the mind control locomotive. The previous figure. Milo implements a novel user interface to allow its user to switch between fully autonomous driving and brain control driving mode. The fully autonomous mode allows the wheelchair to move roughly forward through its environment while automatically avoiding objects in its path, detecting and following walls on either side, and avoiding falls down stairs or steep slopes. These automatic driving features are described in detail in section 2b. When the user wishes to modify Milo's trajectory, a jaw clench is used to enter into Milo's control state, as shown in figure 1. Then to turn left or right, the user imagines moving either the left or right hand, and Milo turns in the. Let me make a winning again. When the user wishes to modify Milo's trajectory, rather than Milo trajectory to modify another thing, a jaw clench is used to enter into Milo's control state as shown in figure 1. Figure 1. And the figure 1. Then to turn left or right, the user imagines moving either the left or right hand, and Milo turns in the described direction before returning to autonomous driving in the new direction. Alternatively, the user can keep their jaw clenched after entering the control state to bring Milo to a complete stop and clench again to resume forward motion. The biosignals and environmental measurements recorded to implement the system are described in detail in section 2a. Inputs and data processing at the system inputs and data processing. Milo collects the following input signals, summarized in figure 2. E.g. signals from the sensory-motor cortex, which with the help of a machine learning algorithm are classified based on new rhythm to detect left or right MI. right. Today distraction. But the premium was check. Right? Okay. එතකොට පොඩ්ඩක් කික් වෙනවා. ඒ වුණාට distractions වල දිගටම රැඳෙන්න ඕනේ. රිප්ලයි කරන්න අවශ්‍යතාවක් නැහැ. අපි යන්න. System inputs and data processing. Milo collects the following input signals summarized in figure 2. AG signals from the sensory-motor cortex, which with the help of a machine learning algorithm are classified based on mu rhythms to detect left or right MI. With the system inputs and data processing ගැන අපි කතා කරන්නේ. මෙතන අපි ගන්නවා Milo collects the following input signals summarized in figure 2. EEG signals from the sensory-motor cortex, in which with the help of machine learning algorithm are classified based on mu rhythms to detect left or right MI. EMG muscular activation recording from the jaw to transition between states. ECG signals from the wrist for user distress signals. Then ultrasound distance measurements collected from ultrasonic sensors mounted on the front of the wheelchair for assisted driving. Ultrasound distance measurement collected from the ultrasonic centers mounted on the front of the wheelchair for assisted driving, and location collected from an Android app installed on the user's phone for emergency caregiver notification. Right. Location collected from an Android app installed on the user's phone for emergency caregiver notification. Specifically, MI is detected by EEG detection of mu rhythms in the left and right hemisphere of the brain. Specifically, MI is detected EEG detection from mu rhythms in the left and right hemispheres of the brain. Mu rhythms are produced in opposite hemispheres of the hand area in the sensory-motor cortex, depending on the hand user's imaging. Methodology. MI is detected from EEG detection of mu rhythms in the left and right hemispheres of the brain. Mu rhythms are produced in opposite hemispheres of the hand area of the sensory-motor cortex, depending on the hand user's imaging mode. When in the control state, logistic regression is used to classify the motor imagery being produced by the wheelchair user. While artifacts can be detected by thresholding the mean power spectral density values, right? When in the control state, logistic regression is used to classify. When in the control state, logistic regression is used to classify the motor imagery based on the live chat. Any guy? What do you also like then? Any guy here? Anybody here? here. Research paper looks to someone, right? Looks to someone. already powerful. Right. Research paper का කියවන එක ගැන idea එකක්. තවද දෙයක් සාමාන්‍ය ඒ කියන්නේ මේක වෙන්න ඕනේ continuously කියවන්නේ. හරිද? ඒ mentality එකේ mindset එක train වෙන එක තමයි එන්න ඕනේ. ඊට අමතරව මේකෙදි ඉගෙන අපි ගන්නා වූ points වැදගත් කියන points ටික අපි අපේ notepad එකට හෝ word pad එකට අපි ගන්නවා. Specifically, MI detected EEG detections of mu rhythms in the left and right hemispheres of the brain. Mu rhythms are produced in opposite hemispheres of the hand area of the sensorimotor cortex. Depending on the hand users, yes, exactly. Good. Right, specifically, MI is detected by the EEG detection of mu rhythms in the left and right hemispheres of the brain. Mu rhythms are produced in opposite hemispheres of the hand area of the sensory motor cortex depending on the hand user's imaging moving. When in the control state, logistic regression is used to classify the motor imagery being produced by the wheelchair user. While artifacts can be detected by thresholding the mean power spectral density. And artifacts detected by thresholding the mean power spectral density values. Regression is required to classify the MI state of the wheelchair user. Artifacts can be detected by regression. Methodology. Right. To do so, the PSD, power spectral density across the mu frequency band are averaged for each time point and fed into logistic regression classified. To do so, PSD across power spectral density across the mu frequency bands are averaged. මේ කොහොමද මේ power spectral density values ගන්න කියන එක අපි මේකේ theory එක තාවම තමයි දැනගන්න වෙන්නේ. මොකද මේ research paper එකකින් අපිට theory එක උගන්වන්නේ නැහැ. research paper එකකින් අපිට උගන්වන්නේ එයාලා use කරපු දේවල් පිළිබඳ පොඩි සංක්ෂිප්ත තත්ත්වයක් විතරයි. ඒත් අපි මේකෙන් බලන්නේ research gap එක එක පුද්ගලයන්ගේ හදපු methods, use කරපු methods, එයාලගේ conclusions, ඒ වගේම future researchers කියන දේවල් දැනගන්න තමයි මේක කියවන්නේ. The most frequent prediction within the duration of the control state, the final decision that is translated to wheelchair motor commands. එතකොට දැන් මේකෙදි මෙයාලා use කරලා තියෙන දේ මෙතන open BCA එකක් එයාලා use කරලා තියෙනවා, right? දැන් මේවා ගෙන්න ගන්න හරි අපහසුයි open BCA. මම මේක කරගෙන යන ගමන් මට කිව්වා මගේ ආදරණීය පුද්ගලයෙක් මට ගෙනත්නා කියලා open BCA එකක්, ඒක දුබයි වල සිට open BCA මොකක් හරි එකක් low cost එකක්. ඒකට මම විශ්වාස කරනවා open BCA එකක් නම් වෙන ගණන් වැඩි. ඒකට මම මේකදී ගන්න Muse2 webpan එකකින් මේක කරගන්න තියෙනවා නම් මට shape එකේ රුපියල් 70000ක් විතර ගේමක් අහගන්න පුළුවන්. right. මම මේ රිසර්ච් එකකට මම high devices කියන එක ගැන හිතන්නේ නැතුව පොඩි ඒ වගේ යන්න බලාපොරොත්තු වෙනවා. එතකොට දැන් මේකෙදි නම් මේකේ යාලා use කරලා තියෙනවා. දැන් මේකෙදි මේක EEG විතරක් නෙවෙයි, යාලා මේ තව sound sensors එකක් use කරලා ඒකෙදි Arduino system එක use කරලා තියෙනවා. ඒකත් මෙතෙත් එකට ඩයග්‍රෑම් එකක් මම දාගත්තා. වැදගත් මම බැලුවම තේරෙනවා ඒක. EG and EMG medical grade 1020 EG conductive paste was used to secure 4 passive gold cup electrodes open BCA New York directly onto the scalp of participants at position. මේ open BCA කියලා කියන්නේ brain signals capture කරන්න පුළුවන් device එකක්. At position C1, C2, C3, C4 in addition to 2 references attached to the earlobes on. ඒතර අපි ඒකේ කොහොමද brain capture කරන විදිය ගැන විස්තරය දෙන්නට ඕනේ. ඒකට අදාළව. එතකොට open BCA එකෙන් ඒ capture කරන්න ඒකේ තියෙනවා scarp position C1, C2, C3, C4 in addition to 2 references attached to the earlobes on A1, A2. ඒක 1020 system එක signals were recorded and digitalized using OpenBCA's Citon biosensing 32-bit board and sample at 250 Hz. Signal quality was verified using OpenBCA graphical user interface, and the noise flow was maintained at 5 to 6 VRMS in contrast with other groups. We do not employ an electrode cap or fasting headband. We do not employ an electrode cap or fasting headband, which improves our system usability by reducing setup time. We do not employ an electrode cap or fastening headband, which improves our system usability by reducing setup time. Increasing comfort for participants and improving signal quality, EMG signals were recorded through the same set of EEG electrodes. Both biosignals were band passed from 5 to 50 Hz using first order Butterworth filter. මේ Butterworth filter කියන්නේ මොකක්ද කියන එක ගැන ඒතර මට දැනගන්න ඕනේ. First order Butterworth filter which was selected due to its maximal flat pass band. The PSD was calculated using the Welch method. ECG heartbeat. The ECG in heartbeat was recorded using single gold cup electrode attached to one of the subject wrists. ECG was also a reference against the earlobes. Peaks in the ECG signals were extracted automatically using a peak detection algorithm. The distance between adjacent peaks correspond to interbeat intervals and the mean heart rate of 5 seconds. Window was calculated from the mean interbeat interval. Ultrasound 4 consumer grade ultrasonic sensors were installed at the base of the wheelchair to measure the distance to obstacles that the wheelchair user might encounter in a natural environment. Ultrasound. It was a ultrasound 4 consumer grade ultrasound sensors were installed. මේ ultrasound sensors install කරලා තියෙනවා wheelchair to measure the distance. ඒ කියන්නේ distance එක measure කරන්න obstacles වල ඉඳලා might encounter in a natural environment. One sensor is pointed directly forward, 2 sensors are pointed 45 degrees on either side of mile, and the 4th sensor is pointed 45 degrees down. The sensors have a minimum usable range of 2 centimeters and maximum range of 4 centimeters. Location. It was an Android application running on Milo's user's smartphone records its position using the Google location servers, which uses either GPS or Wi-Fi to track Milo's position. It's an automated driving system. To enable automated driving systems, the commercially available AutoFab OSIS 2008 wheelchair AutoFab was modified by replacing the footrest with the customized wheels with mount points for ultrasound sensors. The motor controller was placed with 2 commercial grade 40A controls connected to Arduino Uno. This allowed the development of 4 fully automatic driving capabilities: wall flowing, object detection, and avoidance. Development of 4 fully automatic driving capabilities. The automatic driving එකේදී මේ කියන තත්ත්වයන් නැති කරලා තියෙනවා. Wall following, object detection and avoidance, fall prevention, user distress monitoring. For wall following capable. Automatic wall following allows Milo to detect and align itself to straight walls typically encountered in building. Walls are detected by continuous monitoring of the side-pointed ultrasound sensor. The wall ටික මේ detect කරගන්න පුළුවන් මෙතන තියෙන ultrasound sensor එකක් ඒක පාවිච්චි කරලා. Walls are detected by continuous monitoring of the side pointed ultrasound sensor and verifying the local flatness detected in the temporal siding window of 5 seconds by continually filtering linear regression models to the last 5 seconds of distance measurements. A wall is detected if the standard error of the model does not exceed the threshold of 0.1 meters. Right, then you will be mathematical function in Mokatnya here. D or dt Mokatnya C value again minus 0. I mean 5 seconds. Equation 1 is used to determine whether Milo is approaching a wall. C less than 0. Following a wall exactly follow karati C equal to 0 approximately. Approach C to less than 0. Traveling away from the wall, C is greater than 0. Right? The dt function again distance C wall approach. Optimal distance d from walls is given by d equals the maximum of median t belongs to -5 to -5 dt. dt again function again dtd. මේ වගේ එකක් අපි සකස් කරන විදිය ගැන අපිට අයිඩියා එකක් ගන්න පුළුවන්. මම මේක සකස් කරන එක ගැන අයිඩියා එකක් දෙන්නත් ඕනේ. නිසා මම මොකද කරන්නේ? අර මේක ගැන අයිඩියා එක ගන්න මේක මම ෆන්ක්ෂන් එක මෙතන දාගත්තු පොඩි අයිඩියා එකක් මම අලුතෙන්ම මේක ගැන හිතනවා. එතකොට දැන් පොඩ්ඩක් මේ පේපර් එකේදී මට මේක ටික ප්‍රශ්නයක් කියලා දැනුණා මේ ගැන කට පස්කමරන එකද මේ ඉක්වේෂන් එකේදී මොකද අයිඩියා එක ගන්න කියලා දැනගන්න මම එතකොට ඒක ගැන පසු විපරම ගන්නට පුළුවන්. Let's say obstacles directly in front of my lower detected with the distance measurements from the forward facing ultrasound sensor. If the measurements is exceeded by a predetermined threshold and obstacles is detected, if one of the two ultrasound sensors placed 45 degrees to the left and the right unobstructed within reasons, the wheelchair will circumnavigate the obstacles in the direction by moving along the side of the obstacles until it intersects its original forward path, at which point it turns to continue moving in the original direction. Okay. A fall prevention again, some drops such as stairs or steep hills are not navigable by wheelchair systems. The downwards facing sensor continuously monitor for potential force by recording the distance to the ground. The detector is a safe stopping distance. There's a user stress cycle again. Acquired heart rate using ECG is compared to a configurable threshold to detect stress experienced by the user. In this scenario, a caregiver is automatically alerted to the status and location of the user using the Twilio cloud communication platform. Plus, experimental results and brain control of Milo requires a inferring left and right imaging heart apa 10:21යි මම ගත්ත කීයද 9:40ටනේ තාම පැය වෙලා නැහැ brain computer of Milo requires inferring left and right imaging hand movement in real time with machine learning algorithm experimental result එක brain control of Milo requires inferring left and right imaging hand movement in real time with machine learning algorithms to detect mu rhythm suppression in EEG. We developed a protocol to collect MI data for 3 conditions: imagine left hand movement, imagine right hand movement, rest, where participants were asked to not imagine moving either hand. We supply our study participants with 2 forms of neurofeedback to assist in producing turning data and improving MI generation shown in figure 3. We display real-time spectrograms and bar charts reflecting instantaneous mu band power of channel C3 and C4 of the EEG, which corresponds to the right and left hands respectively. Data acquisition. In addition to training a classifier, the make data collect කරන විදිය ගැන කියනවා data acquisition. In addition to training the classifier, we must determine the optimal temporal window and number of channels for our predictions. A pilot cohort of 7 healthy able bodied consenting volunteers mean age එක දක්වලා දෙනවා කලින් ඉන්නේ කවුද ඒකේ females රන් තියෙන්නේ 1 female mean age එක මෙච්චරයි කොච්චරගෙන 7 healthy එක්කෙනෙක් female were recruited to collect the MI training dataset. Participants socio-demographic information is shown in table 1. Participants were students from McGill University and member of the Milo team who were not involved with experimental design. Participants were seated comfortably in front of a laptop screen with ambient noise levels. They were asked to remove any jewelry or glasses and to untie their hair prior to being fitted with electrodes as described in 2A. First, participants were trained to use the neurofeedback dashboard to recognize their resting state. To train participants to recognize the left and right MI states, they were instructed to imagine moving their left or right hand until an ERD in the mu band was observed in the neurofeedback dashboard. Once participants were familiar with the 3 states, an experimental created a series of commands. During each trial, participants were presented with the visual cue indicating whether they should imagine left MI, right MI, or rest. Each trial lasted 10 to 20 seconds, and a single run consisted of repeating trials for approximately 5 minutes. Each participant performed between 4 to 19 runs. An example command series is shown in figure 4 throughout the data collection. AG offline decoding. Initial experiments were performed to decode 3 larger states, left, right, and rest. Based on power in the mu band, power was integrated over a sliding window with lengths of 1 to 4. Sequence in line, previous work. He performs a leave one subject of cross-validation experiments to decode by using 2 channels. Mu wave power as an input feature to a logistic regression classifier. We compare 2 conditions, the length of the sliding window and the number of channels used. These conditions produce between 18,167 and 27,527 data samples to train the logistic regression classifier with dimensionality of either 2 or 4. Figure 5 shows that the 3 states are not easily separated based on power of mu waves as the ratio of mu power is visibly different for the right, left, and mu right, left, and mi, but overlaps with the rest condition. Reading the recording as three-class problem resulted in mean accuracy of 37 plus or minus 2.6%. Even when using the maximum practical window size 4 seconds, it includes all 4 EG channels. These initial results inform our system design where the far more reliable Jouglan GMG signal is used to toggle Milo between fully autonomous and manual BCA mode and simplify the problem to binary predictions of left or right MI. Intersubject classification accuracy with various window sizes and numbers of AG channels is shown in figure 6. Using a 2-second time window, we obtained a mean accuracy of 60 plus or minus 5% using 2 channels and 66 plus 5% using 4 channels across the 7 participants. Mean accuracy was 68 plus or minus 6% when we increased the time window to 4 seconds while keeping only 2 channels. The trades-off between latency, number of channels, and accuracy are well known. Our data show that improvements in accuracy resulting from longer temporal windows and more channels are not significant enough to justify introducing more channels or longer windows, which would reduce comfort, usability, and setup time. We thus recommend the use of a window size of 2 seconds and 2 channels for future real-time decoding experiments. Of note, 3 of 7 participants performed at the near chance levels. Uh, um, Renal- Right. EG offline decoding and initial three target states, left, right, power of the mu band, purpose integrators of a sliding window with the lengths of 1 to 4 seconds in line in the previous work. Each 10 seconds strides was split into this way, applying a various lengths of sliding window with a stride of 0.1, 25 samples. We perform a leave one subject out as validations experiment to decode MI using two channels, a mu wave power as an input feature to a logistic regression classifier. We compare two conditions, the length of the sliding window and the number of channels used. These conditions produce between 167 data samples to train the logistic regression classifier with dimensionality of either 2 or 4. Figure 5 shows that the three states are not easily separated based on power of the mu waves, as the ratio of mu power is visibly different for the right, left hand but overlaps with the rest condition. Treating the decoding as three-class problem resulted in a mean accuracy of 37 plus or minus 2.6% even when using the maximum practical window size of 4 seconds including for each channels. These initial results inform our system design where the far more reliable choke-length change signal is used to toggle milo between fully autonomous and manual PCI mode and simplify the problem to a binary prediction electrode MI. In the subject classification accuracy with various window sizes and numbers of each channel shown. Accuracy near chance. At conclusion, with this work, we have made several important contributions to the state of the art in BCS. State of the art in BCS, our novel system design, which uses the imagery to toggle control of a motorized wheelchair between autonomous mode and brain control mode, solves two challenges that the other groups have not overcome using low-cost EG hardware. First, the autonomous mode address the inability to fine-tune. Autonomous mode addresses the inability to fine-tune a wheelchair's trajectory. Autonomous mode taking address current inability to fine-tune a wheelchair's trajectory, consequences of using a device not intended for high-precision medical applications. Second, the addition of EMG enhances the brain control mode by reducing the number of prediction passes the toggle allows us to achieve EMG, which leads to starting the wind install, which is the user listening. Or should their target be the having overcome the problems of latency, which is inherent to MI production, we are able to include in our system an EEG signals intuitive, wherein the number of electrodes or the length of sliding windows did not significantly impact accuracy in our pilot experiments. Our results showed high variability in accuracy across subjects, which may be related to individual differences such as the placement of electrodes in relation to brain anatomy and the ability to generate MI. In order to enhance MI protection, we focused on the neurofeedback component to train users to generate MI. In my production, we focused on neurofeedback component to train users to generate MI. Interestingly, participants found neurofeedback from the real-time spectrum more informative than the bar plot, specifically 4 to 7 participants. It is important to note that the results presented here were acquired from small cohort able-bodied volunteers who were members of the prototype development team and did not undergo a consistent training procedure. Different number of trial and while we have demonstrated feasibility, future experiments using consistent neurofeedback training procedures in a large number of native participants are required in order to validate our prototype. In addition to future work would involve investigating other signals that do not require muscle movements. Future work would involve investigating other signals that do not require muscle movements that could be used to toggle between the system controls rates, such as EOG, eye blinks, eye glaze blinks, challenge adjusted with using EOG, which would need to be addressed, including the difficulty of quickly and accurately distinguishing voluntary and involuntary eye movements. Finally, we have collected data on and presented the results of offline decoding experiments, but the quantitative validation of the online performance of our major decoders is required. For instance, the performance of the VHR should be quantified while navigating a predetermined set of obstacles. The minor system demonstrates the consumer grade system that potential applications in the practical context of wheelchair navigation. We address the challenges of low classification accuracy and signal redundancy through a neuro feedback training, an EMG consistent control state, and several automated driving features. Our multimodal design, integrating jaw clenching and MI, is a creative approach in bridging the gap between real-time detection of motor imagery and the use of low-cost. Future works right. Technology break at the paper. We go break Let's welcome back. මම දැන් එතකොට මේ ඉවර කරා මේ පේපර් එක. ඒ ගැන සම්පූර්ණ අයිඩියා එකක් අරගෙන තියෙන්නේ. ඒකත් මම දැන් මෙතනින් මේක අයින් කරලා මේක දාගන්නවා මගේ මේකනේ. මේක දාගන්නවා new review කරපු bad collection එකට review R1 එකට. review R1 එකේ දැන් එතකොට මම ජයග්‍රහී ලෙස papers 3ක් සම්පූර්ණයෙන් review කරලා තියෙනවා. ඒව ගැන සංක්ෂිප්ත දේවල් මම දාගෙනක් තියෙනවා. හතරවෙනි එකට යන්නේ දැන් මේ පේපර් එක මට රිවිව් කරගෙන මේ සම්පූර්ණ රිෆර් කරලා ගත උනේ විනාඩි 57ක්. මේකට පැය එකයි කාලා මේකට පැය 3යි ගණන්. ආස්තන වශයෙන් පැය 4ක් කියලා තියෙනවා. ඒක පේනවා වලට කන්ටිනියස්ලි මෙතෙන් දෙtti මගේ ස්පීඩ් එක ගොඩක් ඉන්ක්‍රීස් වෙලා තියෙනවා. ඒක කියන්නේ අකණ්ඩව රිසර්ච් පේපර්ස් කියවන්න ඕනේ කියලා. එහෙම රිසර්ච් පේපර්ස් කියවම අපේ ස්පීඩ් එක සහ අපිටම අනන්‍ය වෙච්ච එක ස්ටයිල්ස් එනවා. ස්පීඩ් එක වැඩි කරගන්න. දැන් බලන්න මම විනාඩි 58ට අඩුවෙන් මේක ඊළඟ එක යන්න ටයිම් එක 10:50ට පටන් ගන්න අපි ඊළඟ එක යමු. ඩිරෙක්ෂන් එකට ගියා. දැන් මම මේක මෙතනින් ඉවර නිසා මෙතන මේක තියාගන්නට අවශ්‍යතාවක් නැහැ. මේක රිවිව් කරලා අවසන් නිසා මම එතනින් මේක කමෙන්ට් එක විචාරේ මේක නේද ඔය ලෝ කොස්ට් ඒක එතනින් ඔන්න ඩිලීට් කරලා දාන්න පුළුවන් නේ. ඊට පස්සේ මම ගන්නවා දැන් මේක multi subject temporal spatial argumentative methods EG based theory of entitlement to speech. The speech එකට සම්බන්ධයි. මේක ගන්නවා මගේ research paper 4 එක R4 කියලා දානවා. ඊට පස්සේ මම මේක මෙතන මේ විදිහට දැම්මා. දැන් මේකේ උතර මම citations එද්දී අංක 4 කියලා තමයි යන්නේ. දැන් මේකේ දැන් මම ඔය උත්තරා ගන්නා දේවල් ටික ඒකේදී දැන් ඔය ගන්නා දේවල් යම් දේවල් දැම්මු. ඒක citation number 4 විදිහට තමයි වැටෙන්නේ. හරි. එහෙනම් යමු දැන් abstract එක ගත්තොත් abstract එක දක්වන්න කියවන්න පුළුවන්. The low signals to noise ratio SNR. Signals to noise ratio is SNR. Neural recording is typically improved by averaging the neural response over repeated trials. The signal to noise ratio of a neural recording is typically signal to noise ratio. Again, noise ratio typically improved by averaging the neural response over repeated trials. Repeat करला मेका accuracy के वर्धने करेगा हम. However, it is not applicable when studying neural entertainment to speech stimuli, in which stimuli are presented only once. Alternatively, multiple subjects' neural responses to the same stimuli can be averaged to decrease unexpected noises caused by breathing. However, it is not applicable when studying neural entertainment to speech stimuli, in which stimuli are presented only once. Alternatively, multiple subjects' neural responses to the same stimuli can be averaged to decrease unexpected noises caused by breathing, lack of attentiveness, etc., excluding those caused by heartbeats and blinking during long auditory tasks. However, individual differences such as varying latency times of the neural responses to the stimuli and electrode positioning to the setup reduce the effectiveness of this method. To eliminate individual differences, we first estimated the importance of each electrode using spatial filter and maximized the SNR by adjusting the latency of the neural response. Then we extracted the common response for all subjects and constructed neural. Then we make a කතාව පැහැදිලි මට මේ කියන්නේ දැන් ඔය SNR කියන ratio එක improve කරන්න පුළුවන් repeated trials වලින්. නැවත නමුත් මේක දැන් entertainment අවස්ථාවකදී මේ වගේ repeated trials කිව්වම ඒකේ අර ඒකට noise ratio එක වැඩි වෙන්නට පුළුවන්. මොකද ඒ අර subject ගේ breath breathing rate එක වැඩි වෙන්න පුළුවන්. හුස්ම ගන්න එක වැඩි වෙන්න පුළුවන්. ඒ වගේම එයාගේ attention level එක අඩු වෙන්න පුළුවන්. එතකොට however, individual differences such as varying latency times of the neural responses to the stimulus and electrode positioning in the setup reduces the effectiveness of this method. ඒ වගේම electrode positioning එක වෙනස් වෙද්දී ඒකේ effectiveness එක අඩු වෙන්නට පුළුවන්. To eliminate individual differences, we first estimated the importance of each electrode using a spatial filter. We first estimate the importance of each electrode using a spatial filter and maximize the instant error by adjusting the latency of the neural response. To eliminate individual differences, we first estimate the importance. Then we extracted the common response for all subjects and constructed neural entertainment models. To eliminate individual differences, we first estimate the importance of each electrode using the spatial filter and maximize the SNR by adjusting the latency of the neural response. Then we extracted the common response for all subjects and constructed neural entertainment modes accordingly. The correlation between then we extracted the common response for all subjects and constructed neural entertainment model accordingly. The correlation between the predicted and actual neural responses obtained in this study much higher than the method again. Abstract abstract a multi-subject temporal spatial hyperalignment method for EG-based neural speech. The correlations between the predicted and actual neural responses obtained in the study were much higher than in other methods in the forward neural encoding method. Laptop fire. Right. The forward neural encoding process. In the decoding process, the correlation between the reconstructed speech envelope and the original also increased significantly in both the delta and theta bands compared with previous studies. Introduction. Speech perception, which links auditory and cognitive process, is the acquisition of communicative information from speech sounds. Speech as perception, which links auditory and cognitive processing, the acquisition of communicative information from speech sound. Speech perception auditory and cognitive processing is acquisition of communicative information from speech sound. One of the main objectives is of auditory and neuroscience research is to investigate how ubiquitous neuronal simulation synchronizes with auditory stimuli. Although invasive methods such as intracranial electrography are external tools explored in this, such methods are not suitable for healthy subjects. Invasive methods are good, but healthy subjects electroencephalography is an effective non-invasive technique for investigating the neural mechanism behind auditory processing. Oscillations observed in the EEG signals are direct reflections of neural oscillations in the cortex. However, the generated electric fields are uh, easily contaminated by external noise. Oscillations observed in the EEG signals are direct reflections of neural oscillations in the cortex. However, the generated electrical fields are easily contaminated by external noise, supplying movement hardware that occur during the transmission from the neural populations to the top layer of the scalp through the brain's tissue and skull. Such a non-invasive technique is often limited by the low signal to such a non-invasive technique is often limited by the low signal to noise ratio of the recording neural signal. Event related potentials is often used to improve the SNR. To make that non-invasive techniques of SNR. The neural response system should be similar across all trials. Considered independent from the response. Thus, the noise can be decreased as a trial is repeated, and the meaning for responses is the ERP can be calculated by averaging the repeats. As such, well-designed trials need to be repeated sufficiently in order to use ERP to improve the SNR. The meaningful response can be calculated by averaging the repeats. As such, well-designed trials need to be repeated. As the noise can be decreased as the trial is repeated, and the meaningful response, the ERP can be calculated by averaging the repeats. As such, well-designed trials need to be repeated sufficiently in order to use ERP to improve the signal. However, it may be impossible to repeatedly conduct trials in certain paradigms. In recent years, studies have extended the controlled experimental paradigm to more natural setting, leading to investigation on how neural activity synchronizes with the acoustic or linguistic information of a continuous naturalistic speech stream. Neural entertainment to speech. In neural entertainment to research stimuli are typically long segments, around 15 seconds to 120 seconds from lectures or stories, and presented to subjects only once to avoid the priming effect. The main problem of these studies is how to accurately estimate the temporal response function of the neural system. Temporal response function. The main problem of this is to how to accurately what's the main temporal response function of the neural system. If we treat the nervous system as a linear system, TRFs can help to linearly map speech simultaneous representations. Example, speech and defined structures like transfers to the neural responses to the listener. TRFs can enable us to investigate how neural oscillations modulate the speech signals or localize the brain regions involved with the speech processing by using the source reconstruction, the method of accurate estimation. TRFs is necessary in studies. As mentioned above, it is impossible to specify ERPs by averaging more trials in the neural entertainment studies. TRFs are often estimated from a single trial. It is difficult to reduce individual noise when using the single trial method. TRFs are often estimated from single thread is difficult to realize. Furthermore, in long listening tasks, it is more difficult to detect unexpected noise caused by breathing or lack attentiveness, which negatively impact the estimation. Assuming brain functions for speech processing are, are consistent across individuals, a similar neural response is expected for the same speech stimulus. In contrast, external noise, involuntary breathing, and attentiveness differ from individuals to individual. Such noises can be suppressed by averaging the neural signal of the same stimuli for all subjects. In our previous work, we have proven the effectiveness of this idea. However, this is suboptimal to apply due to the lack of a method to account for the subject's differences in the latencies from the effectiveness of this idea. However, this is suboptimal to apply due to the lack of a method to account for the subject's differences in the latencies of the neural responses on the domain, as well as differences in setup positions of the electrodes. Addressing these two problems well before averaging the neural activities across multiple subjects should result in a more accurate error estimation. We have found that consistent across individual some brain functions for speech processing are assuming brain functions for speech processing are consistent across individuals. A similar neural response is expected for the same speech stimulus. In contrast, external noise, involuntary breathing, and attentiveness differ from individuals to individuals. Such noise can be suppressed by averaging the neural signals to the same stimulus for subjects. The brain functions for speech processing are consistent across brain functions for speech processing are consistent across individuals. A similar neural responses is expected for the same speech stimulus. In contrast, external noise in involuntary breathing and attentiveness differ from individuals to individuals. Such noises can be surpassed by averaging the neural signals of the same stimuli for all subjects. In our previous works, we have proven the effectiveness of this idea. However, this is suboptimal due to the lack of a method to account for subject differences in the determinants of the neural responses to the stimulus, as well as difference in setup positions of the electrodes. Addressing these two problems well before averaging the neural activities across multiple subjects should result in a more accurate error estimation. Thus, in this study, we propose a temporal spatial hyper-alignment method which uses a well-designed spatial vector to align the latency time at the temporal domain and finds the common neural responses in the spatial domain for eliminating these effects. We propose a temporal spatial hyper-alignment method. The proposed temporal spatial hyper method, which uses a well-designed spatial filter to align the latency time at the temporal domain and finds the common neural response of the spatial domain for eliminating these effects. And then we constructed a neural and then a model to study neural coherence to speech. This paper is organized as follows. Section 2 introduces this experimental design and describes the proposed hyper-alignment testing table uh, materials and methods. Participants: 22 healthy Mandarin Chinese speakers in standard deviation age 22, 9, right, and that were recruited from this university and most advanced. The experiments were conducted in accordance with the acknowledgement by local ethics committee. The subject line informed consent form before the experiment and were paid for the participation afterward. All the subject reported no history of hearing impairments or neurological disorders. Stimuli and experimental procedure. The materials and the participants like the stimuli and experimental procedure. Subjects undertook 24 non-repetitive trials. Each trial was a short story around 60s with the complete storyline recorded by subjects undertook 24 non-repetitive trials. Each trial was a short story around 6 days with complete storyline recorded by a male Chinese announcer in a soundproof room. All stimuli were monospeech within 44.1 kilohertz sampling rate, and the stimuli amplitude were normalized to have the same root mean square intensity. The 24 trials were randomly represented to the subjects. All speech segments were also modified to truncate the silence gap to less than 0.5 seconds. The experiment was carried out in an electronically and magnetically shielded soundproof room. The experiment speech sound were presented to subjects through the subjects undertook 24 non-repetitive trials. Each trial was a short story with the complete storyline recorded by a male Chinese announcer in a soundproof room. All stimuli were monospeech with 44.1 kilohertz sampling rate, and the stimulus amplitude were normalized to have the same root mean square intensity. The 24 trials were randomly presented to the subjects. All speech segments were also modified to truncate the silence gaps to less than 0.5 seconds. The experiment was carried out in an electronically and magnetically shielded soundproof room. In the experiment, speech sounds were presented to subjects through etymologic research insert earphones. During each trial, subjects were instructed to focus on the crosshair mark in the center of the screen, minimizing blinking, head movement, and other bodily movements. There was a 5-second interval between each trial, and the subjects were given 5-minute break every 10 trials. After each story trial, subjects were asked to immediately to answer the multiple choice questions about the content of the story to ensure that they focus on the retrieved task. We embedded unique fonts in some trials to draw more of the subject attention to the stimuli. Subjects were requested to detect the tones and indicate how many times they appear after trials. The EEG data corresponding to the embedded tones were removed in further analysis. EEG data acquisition and preprocessing. The scarp EEG signals was recorded with the 128 channel neuroscan system. Neuroscan music at the sampling rate of 1000 as the electrodes were based according to the standard 10 to 5 system. Physical and 6 channels were used for recording the vertical electrokilogram, horizontal electrokilogram, and 2 mastered signals. The impedance of each electrode was kept below 5. 5 kilo ohm during data acquisition. These subjects' data were discarded in the further analysis because they didn't give a proper answer for the multiple choice questions or electrodes detached during the EEG data recording. The raw EEG data were pre-processed using EEG lab toolbox in MATLAB with the similar determinant science noise and band channels. And preparing the data signals. Then EEG data was bandpass filtered in the delta band. The band and then downstamped in 64. As previous research has shown that speech involves are more relevant to 1 to 8 Hz. We focus on the delta and theta bands in this study. The broadband temporal speech inverse were obtained from Hilbert transforms. Hilbert transform the broadband temporal speech inverse were obtained for the following modeling approach. The envelope was disseminated to the same sampling rate as EEG, enabling us to relate their dynamics to the EEG signals. During the experiment, we marked the time trigger for the EEG signals according to the stimuli onset and offset. In the offline analysis, the 24 data equals 24 stored trials were extracted on the basis of the time trigger for each subjects and subjects into 24 trials, using that all the other membrane to relate their dynamics to the EEG signals to the Users were extracted on the basis of the time trigger for subject 19 subjects into 24 trials. We assume that all the subjects use the same neural mechanism to process the stimulus speech, so their TAs are nearly the same. The average alignments data on all subjects is expected to reduce the noises which may be caused by breathing, inattentiveness, etc. The averaging processing before averaging the spatial filter is designed to align the latency of neural responses for accurately extracting the common neural responses across subjects. Procedure of proposed method. Consider the observed EEG data of signal n at time index t. The RTN is the stimuli-related neural responses. Thus, XTN can be expressed as the procedure of proposed method. Consider XTN is the observed EEG data. Consider XTN is the observed EEG data of channel at time index t. Whereas TN is the residual noise related to the state, including the environment noise caused by breathing, inattentiveness, and unexpected, as we assume that different subjects' brains are functionally similar. The seamlessly related different responses can be expected, and the residual noises rest differ from individual to individual. After averaging the observed zero data, XTN of the same stimuli for all subjects, such noise can be effectively suppressed. However, due to the subject's differences in the latencies of the responses to the stimulus, before averaging latencies or responses for the subjects should be given to different subjects observed each zero data. The proposed method produces partial filters, transform matrices P1, P2, align the latency of neural responses according to our hypothesis after P, optimize the latency of neural responses. The transform result should be similar and both of them have the highest correlation system. Or more importantly, corresponding currents from accordingly our purpose is here we try to explain how to use partial filters to reduce the unrelated residual noise. As partial filters were constructed by optimizing the importance for each processing expression. ඒකට use කරලා මේ equation there is the testing it theory functions with the response latency of the identify the common neural responses and response responses. Then මේකදී දැන් මේ use කරලා තියෙන යාළුවා multiple functions වල මොනවද වෙන්නේ කියන එක ඒ ගැන යාළුවා එහෙම විස්තරයක් ඔබට දෙන්නේ නැහැ. ඒත් අපි මේ තියෙන එකට in-depth අවශ්‍ය නම් අපිට ඒක study කරන්න අවශ්‍යයි. Next to some of the responses of all subjects, the spatial transformation මොනවද මේක ඔයාලට මේ වෙච්ච සිද්ධිය සම්පූර්ණ explain කිරීම අනුවෙන් කරන ඒ කරපු දේ මොකක්ද කියන එක තමයි research paper එකදී විස්තර කරන්නේ. එයාට අයිතිය මේ මම විසින් කරලා තියෙනවා කියන තමයි විස්තරයක් කියන්නේ. Examples of areas Hospitalization of 23 trials were used for training and then one trial was used for testing. In each form, the calls parameters in the different trial we used the average parameters of the forward filter in the further train on the 23 trials. The single trial based method, the forward and backward model was trained based on the subject's neural data. Since each subject took part in 24 trials, the procedure was repeated 24 times for each subject. Our proposed method was trained based on the average subject hyperalignment data, which was repeated for 24 iterations for the hyperalignment data. Our training procedure is shown in the right-hand side. Estimation was partial with the as stated the subsection D. According to the previous research, the total maximum registration is resource behavior research to verify the situations. Present this task. The correlation coefficients. Correlation coefficients. Vicious translation.
Conclusion: in this study, we assume the brain functions for speech processing are consistent across individuals. Based on these assumptions, in this study, on a weekend. I take a finish on the Bible study. Again, විනාඩි 40 finish කරනවා. හොඳයි. ඒත් අපිට දැන් estimate කරගන්න පුළුවන් දැන් මේකේ තියෙන එක දැන් ගොඩාක් මගේ relate වෙන නිසා මම කිව්වේ කොහේ paper එක finish කරා paper එක finish කරාම ඊට කාලේ වෙන දෙයක් ඒකට උනවා ඉස්සෙල්ලා තියෙනවා. දැන් මේකත් දැන් මම දාගෙන multiple processing layer. Democratic data, multi-subject make environment collection, review data, let's say momentum. මේක මම යන රේට් එකට අඩු වෙන්න බෑ. ස්ටාර්ට් කරනවා මේක විනාඩි 11:32 11:40ට ස්ටාර්ට් කරනවා. පොඩි බ්‍රේක් එකක් කොහොමද
Right, so guys, now if I tell you the time, okay, because now only few students are there, I will continue this thing in English because some of the international students also join there. So here onwards, I will continue the thing in English. Uh, so now this is my, I will explain you my roadmap. So I am completely end-to-end explaining how to write the uh, uh, great research paper. So that this is the way I am going. Uh, uh, in that case, I won't explain what are the things I have made here. Basically, uh, sorry. Basically, I have outlined the things, my agenda. I have started yesterday, 3:30 p.m. And I have allocated 15 hours per day. And I'm going to complete this thing within 5 days. By doing a research and also by completing a research paper. So those are the things I have to go. And the main things I have to consider when selecting a research topic: the novelty and the research gap, the significance, commercial viability, and the resource availability. These things you can get the idea from the first session of our live session. Okay, those are the things we have to consider. These are the way of finalizing the topic. So that after that, I have started to read the research papers too in order to get the what we call the I identify the research gap. So I have read, and now already I have read uh, here. If I go to my where I feel the like in the where if I mention this one here, the reviewed R1. So here, this is the reviewed R1. Is it the only two? The only two. Why is that? This is the first thing. Why the other things are not mentioned there? And problem. I know that I have put it to more than two. Where is this? Okay, close this one and go there. Sort of the first paper is EGB is this one towards the EG. And the third thing, I think I didn't put that. Already I have put, I have read 3 papers. So the first is there. Here should be 4 papers. Why it is not like 4? I don't know the reason for that. But we'll discuss it later. The thing. Anyway, so the last paper, I have allocated only, I have got only 40 minutes to complete that paper. Now the next, the new paper, which I have, but I want to read it now. Go to the detection. And this one is the paper that I want to read it now. We'll see, I want to read this thing within like 30 minutes. Now it is 11:45, the time is. We'll see how we read this one. The topic, we first will put the topic. This is R5. It should be R5. Topic is, this thing should be R5. I have to mention this thing as the R5. Shall I put it like R4 is there? For R4, I have taken like R file. I want to finish this thing. So R5, I have to put the topic. Is you can understand why I have put the topic, because now accidentally I have deleted the what we call one of the papers there in the Zotero. So I can again get it because I know the name of the topic, and therefore I can get it. So now I have to study this thing, right? This is R5. Now this is a fifth research paper. 11:45 already passed. Now we can go abstract. We identify the real-time speech, and this is the whole thing we have to put. This the whole thing. Did there? Copy paste it here. Remove it here and paste it here. Right. Any guys who are watching this one now? Continuing in English is a little bit easy because the same thing is there. Therefore, I can also here. So Vitura is there now. Let's see now. Right. We'll see how do we go through the research paper. Right, what is the meaning of this? A non-invasive brain-computer interface for real-time speech synthesis. A non-invasive brain-computer interface for real-time speech synthesis. To generate speech, it is used a non-invasive brain-computer interface, and they are discussing the importance of multimodal feedback. Multimodal feedback. Now, at the moment, I do not know what is this multimodal feedback. I have to go through this paper and identify that one. I will put my there. Right, we conduct a study of a motor imaginary brain-computer interface using electroencephalography to continuously control format frequency speech synthesizer with instantaneous auditory and visual feedback. Over a 3-session training period, 16 participants learned to control the BCF of production of 3 vowel sounds. These vowel sounds and were split into 3 groups: those receiving unimodal auditory feedback of synthesized speech, those receiving unimodal visual feedback of formal frequencies, and those receiving multimodal audio-visual feedback. Audio feedback was provided by a formal frequency artificial speech synthesizer, and visual feedback was given as a 2D cursor on the graphical representation of the plane defined by the first 2 formal frequencies. We found that combined AV feedback led to the greatest performance in terms of present accuracy, distance to target, and moment time to target compared with either unimodal feedback of auditory or visual information. These results indicate that performance is enhanced when multimodal feedback is meaningful for the BCI task calls rather than as a generic biofeedback signal of BCI progress. Right, what is the meaning of this one? These guys, they have studied about motor imagery brain-computer interface using electroencephalography to continuously control a formal frequency speech. This thing is their study, so I will take this thing, control format. Motor imaginary brain-computer interface using electroencephalography to continuously control a formal frequency speech synthesizer with instantaneous auditory and visual feedback. Right. That is the main idea of this one. So I will take this one. It is the abstract here. Control V, and we know that it is as the abstract. Abstract. Okay, I got the idea here, and then we move to this one. Right. Brain-computer interface for communication have a number of possible applications, including silent speech and restoration of communication output of individuals with profound speech and motor impairments. Most often, BCS are thought of as a method of last resort for individuals who cannot speak due to neurological disease or injury, and cannot use existing forms of augmentative and alternative communication. Individuals commonly considered for BCA intervention uh, quadruply include those with quadriplegia, with anatra due to locked-in syndrome, or neurodegenerative disease such as uh, amyotrophic lateral sclerosis. They have mentioned that on there. Most non-invasive VC applications for communication employ discrete typing interfaces using event-related potentials such as P300, steady-state oscillations, or neurological rhythms related to cognitive motor processing. Now, you guys, I can understand now. I have already read 4 papers there. There, I understood about this P300 and SSVP and the drawbacks of those things. So I do not want to again rewrite the things. These approaches have been largely successful and have provided a new avenue for written communication for at-home users, with spoken communication possible through text-to-speech synthesis. Text-to-speech. New avenue for written communication for at-home users, with spoken communication possible through text-to-speech synthesis. Another approach to VCI-based communication is to directly decode intended speeches from neurological activity using intraclinical recordings. Only a few studies of non-invasive VCI have attempted to decode speech using electroencephalography and have focused on discrete predictions and selections of internal spoken words. Now, this is only few studies focus on discrete prediction and selected internal spoken words and vowels from small dictionary of possible items. Well, that means that is their research area. Right. So I will put this in as the one. Now, sorry. In contrast to typing and single word vowel prediction, which rely on discrete reselection, the motor and acoustic basis of speech productions and perceptions are the result of, in contrast to typing and single word vowel prediction, which rely on discrete selections, the motor and acoustic basis of speech productions and perceptions are the result of continued processes of speech motor articulation and generation, speech motor articulation and generation receptions of a time varying acoustic signal. The continuous auditory output of speech production is then transformed into discrete phonetic syllables and word-based representations for speech perceptions and language comprehension. In contrast to typing and single word vowel prediction, which rely on discrete selections, the motor and acoustic basis of speech productions and perceptions are the result of continuous processes of speech motor articulation and generation receptions of a time-varying acoustic signal. The continuous auditory output of speech production is then transformed into discrete phonetic syllables and word-based representations for speech perceptions and language comprehension. These same process hold true for perception of self-produced speech. Continuous movement of the speech articulators are used to generate an acoustic signal that is perceived by oneself to maintain error-free productions and to adjust to error when occur during speech movements, and the speech articulators alter the vocal tract resonance, which is measured acoustically as format frequencies on formats. Most monophonic vowels can be represented by just the first two formats, making them
and ideal low-dimensional representations of speech for BCA applications. Additionally, they can be readily synthesized into artificial speech sounds with minimal computational overhead. Um, we propose an alternative BCA system for communication in which EEG activity related to motor imagery is used to directly and continuously control a two-dimensional four-mount vector that can be represented graphically as a 2D cursor. We propose an alternative BCA system for communication in which EEG activity related to motor imagery is used to directly and continuously control a two-dimensional four-mount vector that can be presented graphically as a 2D cursor or synthesized in real for instantaneous auditory feedback. Synthesis in real-time instantaneous auditory feedback. Other studies have investigated four-month synthesis for auditory feedback via intracortical neural prosthesis for speech and surface electromyography. In the current study, we extend these efforts and investigate EEG as possible signals modality and limb motor imagery as the mental control strategy, which draws from prior work on continuous cursor control via BCA. Further, we explicitly examine the role of feedback modality on BCA performance by examining three separate participants groups. Those receiving unimodal feedback of visual of auditory information, and those receiving multimodal audio visualization information. Prior studies investigating BCA feedback modality have found that unimodal feedback of visual information typically prior studies investigating the AG as a possible signal modality and limb motor imagery as the mental control strategy, which draws from prior work on continuous cursor control via BCA. Further, we explicitly examine the role of feedback modality on BCA performance by examining these separate participants groups, those receiving unimodal feedback of visual or auditory information. Unimodal feedback, that means only one mode is used, feedback of visual or auditory information, and those receiving multimodal audio visual, and those receiving multimodal audio visual information. Prior studies, I will take this one. Sorry, prior studies investigating BCA feedback modality have found that unimodal feedback of visual information typically leads to enhanced BCA performance, and that unimodal auditory feedback suffers in terms of present accuracy and learning time. Past studies involving auditory feedback for motor BCA use generic audio stimuli as an indicator of BCA performance and success. Combined multimodal audio visual feedback has also underperformed relative to unimodal visual feedback, possibly due to an over-reliance on visual information. Combined multimodal audio feedbacks has also underperformed relative to unimodal visual information. We have human feedback. Present accuracy as a feedback program. Private also says that visual feedback using cursor position information will likely lead to greater performance compared to auditory feedback alone. Though it is possible that after a short training period, performance will be equal for both unilateral feedback conditions. In our experiments, we hypothesize that the addition of speech-related auditory information instead of generic audio signals to conventional 2D cursor visual feedback will enhance BCI performance in a vowel production task. In our experiment, we hypothesize that the addition of speech-related auditory information instead of generic audio signal to conventional 2D cursor visual feedback will in the vowel. Participants, we recruited 18 adults from University of Kansas to participate in 3 sessions BCI-based vowel production study for native speakers significant English, self-referential normal speech, language and hearing with no known neurological or neuromotor impairments, and received more monetary compensation for their time. All study procedures were approved by the Institution Review Board of the University of Kansas, and all participants provide their informed consent prior to engaging in study activities. Procedure. Study protocol. The participants were grouped into 3 conditions: those receiving unimodal auditory feedback of synthesized vowel sounds. Study protocol, the participants were grouped into 3 conditions: those receiving unimodal auditory feedback of synthesized vowel sounds, unimodal visual feedback of the 2D vowel formats, and multimodal audio visual feedback of vowel sounds. Shows a visual depiction of the relationship between formants and vowels used American English. In this study, the cursor represents the instantaneous formants estimate, and the text locations represents the large vowel centers on the formant square. Only examples of synthesis vowels and providing supplementary material. During the initial sessions, participants first completed a screening questionnaire to ensure that met the inclusion criteria of native fluency in American English and did not have any metallic cranial implants. The remaining study procedures were identical for all 3 sessions. Training data was collected at the start of each session, in which participants were presented with 30 repetitors of the vowel stimuli. The visual formats of both in random order for 3 seconds each, and were instructed to make one of 3 movements using kinesthetic motor imagery in response to the vowel stimuli. Left hand for the vowel, right hand for AA, and bilateral feet for IV. Model weight were then estimated for a Kalman filter BCI decoder based on the training data and used for online BCI control. Online test trials involved a short 1.5 seconds presentation of the target vowel followed by a 1 second palm interval and a 6 second response period, in which participants were instructed to make the appropriate imaging movement to direct the BCI toward the target. In real-time visual cursor movements and audio synthesized vowel sounds feedback was provided to the participants to the response period, which began with former values in the center of the vowel space. Example, neural vowel online test trials involved sort of was provided to the participants to the response period, which the center of the vowel space and natural vowel sounds. Participants were instructed to use model to summarize the BCI could begin producing this output in order to move the decoded performance away from initial neural values such that they match the target stimulus, while avoiding other vowels or the BCI output within the target region as long as possible. In the visual domain, holding the target in place requires participants to match cursor position with the circular target regions on Visual feedback of the 2D performance. What is your feedback for this? The first format, the format. In real time using the same as visual feedback. EG acquisition, all EG recordings were obtained using 64 channel acquisition system with 64 active electrodes for recording the EG. And then otherwise there. But I'm continuing this EG acquisition. All EG recordings were obtained with 64 GTEC device. We have used GTEC device with 64 active electrodes for recording energy. Tintin standards. Was monitored with the EG from electrodes 7 inches. Was the transfer recorded at a 256 sample rate. And transmitted to a network of computer for real-time results. Offline and online preprocessing. Offline analysis of training data and similar data processing. Offline analysis of training data. Real-time analysis of online styles. Now similar data processing procedures for training data analysis. 1 Hz high-pass filter was applied to the raw data, followed by electrocrystallography card that remove the independent components analysis. What is this independent component analysis? Visual inspection of power spectrometry. Filter decoder. A new decoder was trained at the beginning of every decision to account for any possible changes in electrode position or relative to amplitude of new and future results. During test trials, stored values from the offline analysis were used to implement implement offline filtering and band power estimation. Independent component analysis was not used since current methods for independent component analysis rejection require as much as 3 seconds of data, which is too slow for real-time audio-visual feedback of speech sound. Instead, any recorded signal greater than magnitude was marked. A common filter decoding algorithm was used to convert recorded sensorimeter rhythms into 2D format velocity vector, which was integrated for audio and or visual feedback. In this implementation, the output state model represents velocities in the 2D format space and is given by VCA decoder. Matrix describes a parity probabilities of future performance velocities based on past estimations. Signals and is represented by first order auto-repressing model. The likelihood of model represents the relationship between form and velocities and anticipated modulations in the sensorimeter rhythms over all features. Combine mu and beta and power for all electrodes is given by this one. The n into 2 likelihood matrix, which is a linear model of the relationship between the observed sensorimeter rhythm in a given form and velocity vector. There are terms in equation 1 and 2 Gaussian random variables in 0W and Q respectively. And the 2 to 2 matrix W is the state model residual covariance while the n matrix Q is the likelihood model residual covariance. The choice of the current features was made based on the presence of the meaning of beta rhythm provides no observable listening system. Just for us, several features. This was made based on the principles. The choice of recording features was made based on that. But as notes, normally to the feedback features. Performance sensitive coded. It's a version of that. And then this classification. This is the first dimension. These perceptions is separated and the auditory targets for person to represent ideal box. Estimating now I've seen here we evaluated the statistical significance of each performance measure, accuracy endpoints, distance, movement, and duration. Choosing three-factor mixed models analysis of variance to determine the effects of feedback in subjects. Sessions within and with the visual subjects. Participants were included in all modules as a random purpose. Results SMR bands and model train. The new band was not observed for 2 participants, and the power spectral density was similar in shape to a 1 over F distribution at this frequency. These participants were excluded from any further analysis, as in the beta rhythm was not observed in 10 participants, and in at least 5 experimental sessions, the government was trained on the new band features in the beta. It was not observed in order to estimate the most fast decoding model and in their conclusion, otherwise the average range of the new rhythm was 8.13 to 13.31 Hz and 17.64 in the beta rhythm. Shows the R square values for each new band dimensional in the beta at 2 for 1 participant. In this example, electrodes that contribute most to decoding go over the left and right sensory regions and frontal regions in the skull. BC performance. Here I want to say that these are the results that they have got. More than one pleasant division. Overall, we found that receiving either visual or audio feedback alone was equally useful for speech synthesis research, but resulted in lower performance compared to combined audio visual. nearly all invasive BCI for communication typing or spelling communication output. In the current study, we develop BCI that addresses each of the issues. Direct switch output using a MNC, which is the sensitivity paradigm. Instantaneous audio feedback to engage the error process involving speech detection. Hey guys, මම ඉවර කරා මේ research paper එක කියව එක විනාඩි ඉතින් විනාඩි 40 ගානක් විනාඩි 40ට අඩුවෙන් ගිහින් තියෙන්නේ නෑ විනාඩි 40ට වැඩි ඉන්නේ 12:50 අපේ time එක තිබ්බේ 12:40 විනාඩි 50යි විනාඩි 47ක් වගේ ප්‍රමාණයක් ගිහිල්ලා තියෙන එක ස්ටඩි කරන්න එක ටිකක් deep study එකක් I will put this thing also into my Auditory folder. This one. To collection review. Right. So I have to get the break now. 12:38. I'll meet up at 2 p.m. Okay, guys. Bye.